sing. I'm trying.
Hello, NDC. Welcome, everybody. So I love the thing, like, half of you live here, and I don't, but I can welcome you to Oslo, and that's just fine, right? So if you enjoyed those little opening reels, I got one thing to plug before we get into the serious business of free software. Those are all my band, Line Breakers, and we are playing the NDC party here Thursday, and then on Friday we're going to be at Brugata, just around the back. Big free after party with beer and nerdy comedy rock music, and you are all invited, and it will be awesome to see you there. And now, let's talk about free software. Now, there's an emotional cycle that I'm sure a lot of you folks in this room can relate to. And it starts like this. It starts with shiny. It starts with desire. There is a new thing that you have seen, and you need it. And yesterday you didn't know it exists. But now you must have it in your life or you will never be happy. And it might be a phone or a laptop or a gadget or a plugin or any one of these things. You're like, I need it, I need it, I need it. And then you get it. And you open it, and you configure it, and you install it, and you're thinking, I can't wait to see what this thing can do. And then there's doubt. There's that moment where you're like, hey, I got this amazing smartwatch, and I'm sure that the website said that it could play MP3s, but the only option here is to add a Deezer subscription, whatever that is. You've got that amazing new CRM package that everyone says is brilliant. And yes, the sales rep said, absolutely, you can deploy your custom workflows from GitHub. But there's no GitHub plugin. All there is a button to upload some XML from your desktop. And that's the point where you realize that this gadget, this system, it has the capability to do what you want. It's got all the right bits. They're just not quite set up properly. You need to tweak it. You need to hack it. You need to make this thing work the way you want it to. Now, for me, this is one of the defining characteristics of a true hacker. All you folks out there who've got your IDE set up just the way you like it, with your colors and your background and your plugins, your fonts, your everything. You know, the kind of people, if something doesn't work the way they want it, they don't send it back, they don't complain. You just roll up your sleeves, you get to work. You're like, let's make this into the thing that I want. And to that kind of hacker, the worst thing you can do is say no. You can't do that. You're not allowed to do that. We are not going to let you do that. Not for a technical reason, just because we said no. In 1980, Xerox donated a laser printer to the Artificial Intelligence Laboratory at MIT, Massachusetts Institute of Technology. In 1980, we were about 2 years away from general AI. And we've been 2 years away from general AI ever since, and we're about 2 years away from general AI. Now, Xerox and MIT, they're both really, really big names in the history of information technology. Xerox invented loads of amazing things. They invented mice, they invented Windows, they invented all this great stuff, and they completely failed to sell any of it because they were terrified of jeopardizing their photocopier business, which is why Xerox still make photocopiers. MIT, they invented functional programming. They invented passwords. They invented Ethernet. They invented email. They invented the Roomba. They invented blockchain. And maybe they also invented free software. You see, the laser printer had a problem. It was, now just checking, you folks, you do know what a photocopier is, right? I'm aware there's a generation gap in the audience, but you know the thing where you're making some copies and it jams, and you open up the door and the paper is all kind of crumpled up, and so you kind of tease it out like you're persuading the dog to let go of it, and then you close the door, and off you go, and it keeps making your copies. Now, when a photocopier jams, you're stood right there, because you're making your copies, and it jams, and you're like, and you fix it and get it going again, get your copies and go. But a laser printer, that's on the other side of the room, maybe the other side of the building. So you send your print, and you go, yep, I'll pick that up in a minute. And then you go to get a cup of coffee, and you get to the printer, you're like, oh, it's jammed. And you're like, it's been jammed all morning. It's been jammed since 10 o'clock. My job is number 17, and the queue hasn't moved for 3 hours. So you unjam it, and you fix it, and you put it back together, and you get another cup of coffee. Now, one of the people working at MIT in 1980 was this guy, Richard Stallman. And a lot of people have opinions about RMS, Richard Stallman, but I don't think you can talk about the history of free software without acknowledging the pivotal role that he has played in it. Now, his idea was this is a network printer. It knows when it's jammed. Why don't we just modify the software so that if it jams, it'll tell everyone on the network, hey, someone come and unjam the printer? Seems like a good solution, right? So he went to Xerox and he said, can I have the source code for the printer? Xerox said, no. We're not going to give that to you. The printer was free. Go away. We're not sharing source with you. Now, there are two versions of this story. There is the interpretation that says this incident galvanized Richard Stallman into spending the rest of his life committed to the idea of free and open software. There is an interpretation that says it pissed him off so much he's still angry about it 40 years later. I think both interpretations are kind of true. But, you know, this incident, he's spoken several times about the MIT laser printer and how that inspired his dedication to the cause of free software. Now, when talking about free software, we need to understand what free means. Because historically, there have been two kinds of free that people talk about. There is free as in free beer, and there is free as in free speech. And let's talk about free beer for a second, because beer is a great example of a certain kind of freedom. Anyone want a beer? Yeah, I mean, yeah, because this is Norway, right? Free beer is a signal. If I give you a beer, yeah, you have a beer now. Brilliant, excellent, and you didn't pay any money for it. Big deal. Now, what can you do with that beer? Well, you can drink it. Well, maybe you can drink it. Maybe you can't drink it because you're taking medication. Maybe you can't drink it because you're driving. Maybe you can't drink it for religious reasons. Maybe you can't drink it because you're 12. So now you have a beer you can't drink. Could you keep it? Nah, not really. Beer doesn't last very long and once it's in the mug. Can you sell it? What happens if you try and sell beer without a license? Yeah, it's free. It's free as in it didn't cost you any money, but you don't have any freedom. You can drink it or you can throw it away. That's really the only thing you can do with it. And the world is full of software that is free because we don't pay money for it. But any of you folks, you know, Instagram, Facebook, Spotify, Gmail, Google Drive, all these things, they don't cost money, but they don't give you any freedom at all. You are completely restricted in what you can do with those applications. Now, let me ask you what might sound like a weird question. Anyone in here, raise your hand if you own second-hand software. I mean, software is valuable, right? And there might be a couple of people who've got like an old copy of Windows 95 they bought on eBay or something. Second-hand software today is a curiosity. It's museum pieces and people collecting boxes and stuff. Because we don't really own software anymore. So the idea of buying it and then when you finished it, you sell it, it doesn't make any sense. Valve actually had a thing last week where they said legally, no, if you die, you cannot leave your Steam library in your will. You can't pass it on to someone else after your death. They said, you know, you spent all this money, thousands of games, you don't own them. They're not yours and you can't control what happens to them after you die. But it hasn't always been like this. When I was a kid, a lot of computer software came in cartridges. Any Sonic Hedgehog fans out there in the house today? And the software was so inextricably linked to the packaging that you could actually treat the game as a commodity. You could buy it, you could play it, and when you finished it, you could sell it. You could loan it to your friends. You could rent it out. You could go to a video store, and you could rent Sonic Hedgehog for the weekend, try and finish it, and then get it back on Monday. Now, when I was a kid at school in the UK, late 80s, early 90s, there were two kinds of kids in my school. There were the console kids and the computer kids. And the console kids, they had short hair, shaved heads, they had skateboards. They were always in trouble for setting stuff on fire. The computer kids had long hair and mountain bikes, and we also set stuff on fire, but we were smart enough not to get caught. And if we wanted to play computer games, we had a choice. We could buy them. We could go down to a store and we could buy X-Wing, or we could buy Dungeons & Dragons, Eye of the Beholder, or Monkey Island. These cost about £25. Now, to put that in perspective, I'm 12 years old. That's the same as 25 Big Macs or a new pair of jeans. You know, it's a substantial investment for a teenager whose only income is their allowance. Or we could pirate them. It says it right there on the copy protection, dial a pirate. Hey, Steve, have you got the new Monkey Island game? Now, the computer game companies, they tried really hard to stop us copying games. But there is no copy protection system that is smarter than a really bored teenager with lots of time and no money. We figured out how to make the decoder rings work. We figured out how to copy the hidden sectors on the drives from one thing to another. Now, piracy, if you made 100 copies of Monkey Island and you sold them at a market, maybe the police would get involved. But kids swapping games in the playground, we knew it was illegal, we just didn't care. But there was a third option. In the classified adverts at the back of the magazines, there were companies that sold free software. You'd send them a couple of dollars or a couple of pounds, and they'd send you a disk of free software. Now, a lot of this was something called shareware. And the idea with shareware, sometimes they'd say, here's the full program, I made it for fun, but if you like it, send me a check, send me some money. Some of them were like, I don't actually want your money, but send me a postcard, because it's nice to feel the love. Some of it was cut down restrictions. Some software was literally in the public domain. The people who created it, not only had they said, no copyright, it's just out there, they took their contact details off. You couldn't pay them for it even if you wanted to. You had no way of reaching them. But the most successful shareware model, the one that I think really kind of turned the tide on this chapter of free software distribution, was pioneered by this guy. This is Scott Miller. He founded Apogee Software, and he had written a game called Kingdom of Kroz for the IBM PC, and this game was too big to fit on one disk. So he had an idea. He's like, I'm going to put episode 1 on a disk, and that one's the one you can copy, and you can sell, and you can download it from your bulletin board, and it's free. And when you got to the end, a little screen popped up saying, hey, if you enjoyed that, send a check to this mailing address, which was his parents' house, and I'll send you episodes 2 and 3. Kingdom of Kroz made $100,000 in the late 1980s. Big deal. A couple of years later, Scott Miller gets a copy of this. Dangerous Dave, written by a company called SoftDisk, a developer called John Romero. Now, John Romero and his colleagues John Carmack and Tom Hall, they had a game development group called Ideas from the Deep. And Ideas from the Deep became id, and became ID, and then ID became id. And John Carmack, one of the best graphics programmers in history, he was kind of the first person who figured out how to do smooth scrolling graphics on an IBM PC. And so they stayed up all weekend, and they ported Super Mario to the PC. And they sent a copy to Nintendo and said, are you interested in this? And Nintendo said, this is brilliant, bury it. We never, ever want to see Nintendo games, because Nintendo wanted to sell consoles and they wanted to sell cartridges. They didn't want kids swapping copies of Super Mario in the schoolyard, right? And so Scott Miller from Apogee, he gets hold of this. He gets in touch with John Romero, John Carmack, and he says, look, this technology is amazing. How about you make an original game, and we'll put it out on my Apogee shareware label, and episode 1 will be free, and then we'll sell episodes 2 and 3. And that game was Commander Keen, Invasion of the Vorticons, which is an 8-year-old boy genius who has to reassemble his spacecraft using his football helmet and his pogo stick. I loved this game, and I was not the only one. This game made so much money. It made something like $100,000 in 3 weeks. It made so much money that they all quit their jobs, they went into game development full-time, and created some of the most influential games in the history of PC gaming. In 1992, Wolfenstein 3D was the first-person shooter, like the first person where you could actually run around corners and this kind of thing. A couple of years later, Doom came out. Doom crashed every college network in America because it had multiplayer network deathmatch. And nobody had done that before, and it was awesome. And then a couple of years after that, in 1996, Quake. Quake was the first completely 3D shooter. Quake was one of the first games that supported 3D accelerator cards. My friends and I stayed up playing Quake for like upwards of 30 straight hours without sleeping or anything. These were some seriously excellent games, but each of them also represented a paradigm shift in the way software was distributed. I got Wolfenstein free on the cover of PC Format magazine. I copied Doom off a friend of mine at school, and I downloaded Quake from the id Software website in 1997, because this is the point in history where a lot of people, including me, were getting a modem, and we're getting online, we're getting email, we're getting access to the internet, the web is taking off, the dot-com boom is coming. And as we all rush online and go, yeah, this is awesome, we encountered a community of people who had been online for a lot longer than any of us had. And they had some ideas of their own about free software that did not have anything to do with coming free on the cover of a magazine. To them, software freedom was about the 4 essential freedoms. Freedom 0, the freedom to run the program however you want for any purpose. The freedom to study how the program works and modify it to do what you want. So it goes without saying, you need the source code. The freedom to distribute copies, and the freedom to share your own modifications. Now, these 4 principles, these are the underlying ethos of something called the GNU project. This was set up by, there you go, get a picture of the freedoms. Go on, it's fine, it's cool. These were the fundamental principles behind the founding of something called the GNU project. Set up by Richard Stallman in the early 1980s with the explicit objective of building a completely free, open operating system. By 1991, they had most of it. They just didn't have a kernel. This is a bit like saying, yeah, I've almost built a car. I got wheels, I got a steering wheel, I got the leather seats, and I got the stereo and the windscreen. Just having a bit of trouble with the engine, you know? And perhaps more significantly, along the way, they had created something called the GNU General Public License. This was in theory, a legally binding document that permitted and enforced the distribution of free software. Then 1991, this guy, Linus Torvalds, he's an undergraduate student at the University of Helsinki, and he says, hey everyone, I'm doing a free operating system. It's just a hobby. It won't be big and professional like GNU for 386 clones. And most significantly, he published his Linux kernel under the GPL. A couple of months later, the system became self-hosting. You could use a GNU Linux computer to work on GNU Linux and build your own tools. And for the first time, we had a completely free operating system whose freedom was enshrined in a legal document. Now, it's probably a good point to ask why. You know, why did all of these people decide to put their code out there for free? Now, I think Linus Torvalds, if you'd gone to him in 1991 and said, you know your little hobby project, you know one day that's going to run half the internet and 8 billion Android phones, he would have had no clue. I think he was doing it for fun. He was really enjoyed the craft of programming and the intellectual challenge of building his own kernel, and he wanted to share his work and show everyone what he did. I'm pretty sure the folks at id Software, I was at We Are Developers in Berlin last year. John Romero was one of the speakers there. That guy still loves gaming. Like, he made so much money that he went out and he bought a Ferrari and then he gave it away in a competition, and he still writes code every day because he loves programming. And I'm pretty sure the folks at id Software, they just wrote the games that they wanted to play, and shareware was a really good way of making enough money that they could spend more time writing games and playing games and improving games and doing all that kind of stuff. But for Stallman and the GNU project, I think software to them was the executable expression of their ideology. They wrote free software because they believed free software was going to make the world a better place. Now, you'll also notice we're about 20 minutes into this session now. I haven't mentioned the words open source yet. And that's because at this point in history, the late 1990s, nobody had mentioned the words open source yet. That phrase did not exist. But the late 90s was a really interesting period for software. The kind of desktop empire was just beginning to crumble around the edges. Lots of companies were like, the web. We need to do web. Can you do web? And they would hire webmaster. That was my job for a while. And webmaster had nothing to do with corporate IT. You got sat in a corner by yourself to do your own thing. And they needed software. They needed internet server-capable applications and servers and platforms. And if any of you folks ever tried running a website on Windows 95, that was some bad business. That was not a good way to do it. And companies saw an opportunity. You know, there's all these potential customers out there. They need enterprise-grade server-quality operating systems. Those are available for free on the internet for no money if you know how to download them and compile them and install them and configure them and set them up. And a lot of companies and clients, they didn't want to do that. They just we want to give you money, and we want to get software with a help desk number on the back, and if it doesn't work, we'll phone you and you can help us set it up. And so companies like Red Hat saw this opportunity, and they sprang in and went, we can do that. We'll download all the packages, we'll compile them, we'll make sure they work, we'll put them on a CD-ROM and put them in a box, and we'll sell it. And we'll sell you free software for only $80. And a lot of companies went, what do you mean free software for $80? What? And this word free was a problem. It was a real kind of barrier to entry for commercializing what would become known as open source. Now, the person who actually coined that phrase was this lady, Christine Peterson. And she was involved in a lot of meetings around 97, 98 with a lot of the other folks who were very prominent in this scene. And as she says it herself, those new to the term free software assume it's referring to price. And old-timers must then launch into an explanation, usually given as follows: we mean free as in freedom, not free as in beer. And at this point, a discussion about software has turned into one about the price of an alcoholic beverage. This is how it plays out every time. And she said, you know, between meetings, I was still focused on the need for a better name. I came up with the term open source software. And this kind of stuck. A week later, Eric Raymond and Bruce Perens, they created opensource.org. The first kind of flagship presence on the internet for this term open source and this idea. A couple of months later, Tim O'Reilly was organizing a big free software convention, which became known as the Open Source Software Convention. The name stuck and a new movement had kicked in. And ostensibly, it was about getting away from this word free, but it was also about addressing something that was perceived as a growing problem for the commercialization of free and open source software. The GPL, the GNU General Public License, is sometimes referred to as a viral license because of this clause: you may not impose any further restrictions on the recipient's exercise of the rights granted herein. You cannot take GPL software and make it closed. And the mechanism that they use to do this is interesting because it operates on copyright. If any of you folks in here has contributed code to .NET, you'll have signed a license agreement which transfers your copyright and your ownership to the .NET Foundation. If you've contributed to React, you'll have signed an agreement that says that Meta owns that contribution. If you've contributed code to Linux or to any of the GNU tools, that code is still yours. If you have one line of code in the Linux kernel, that line of code is your line of code. You are the author. That means you wrote the Linux kernel, as far as the law is concerned, and you are allowing people to use your work, which is copyrighted, under the conditions of a license. And if they violate that license, you can sue them. Now, this was purely hypothetical for a long while, until about early 2000s, 2002. This thing is the Linksys WRT54G. It was a really popular home broadband router. It's got a Wi-Fi chip, it's got 4 network ports, it cost about $100, $120. They sold 250,000 of these things in the space of 3 months. And then a guy called Andrew Vickless, who, if any of you knows the company PagerDuty, Andrew went on to found PagerDuty after this, but he was on the Linux kernel mailing list. And he pulled down the firmware for the Linksys router, he opened up the binary file, and he went, there's a Linux or a GNU Linux operating system in this thing. There's a Linux kernel, there's all this networking code, that is GPL code, and I don't see the source anywhere. They are not respecting our 4 essential freedoms. And so he got in touch with the Free Software Foundation, and he said, I think we might be onto something here. Now, the reason this was interesting is that this Linksys router had a bunch of Broadcom wireless networking chips in it. And this is the day when Wi-Fi didn't work on Linux. It was so difficult getting anything to connect. And so whoever built this, they'd taken the Linux kernel and they'd added support for all these Wi-Fi chips. And the community really wanted those drivers. And so the Free Software Foundation, now this is the bit where I can't quite make the pieces add up. In 2003, oh, hello. That's fun. All right, so in 2003, intermittently flickering. Let's see, is it just that slide it doesn't like? Yeah. Look at that, the projector doesn't work with Slashdot. So I'm going to tell you, that's a story from Slashdot from 2003 about D-Link releasing, or the thingy, Linksys releasing the source code for that router. Now, Linksys had been acquired by Cisco while all this was going on. Cisco accidentally bought a lawsuit and went, oh, crap. What did we do? And I went, all right. Now, 5 years later, 2008, the Free Software Foundation sues Cisco over the open source code. Now, I don't know what happened in the intervening 5 years. I suspect what happened is that Cisco went, look, just put the source code on an FTP server and they'll go away and stop hassling us. And the Free Software Foundation went, if we can get this to court and we can get a judge to rule on it, we can have a precedent that the GPL is legally binding in the United States, so we're not going to let this one go without a fight. It bounced backwards and forwards until in 2009, the case was settled out of court. Now, this means Cisco sat down with a bunch of their lawyers, and the lawyers went, don't take this one to court. You know, don't try and fight this. You might lose, and that wouldn't be a good look. And so Cisco made a big donation to the Free Software Foundation. They established a compliance director. They published all the source code, agreed to do that going forward. The only time, as far as I've been able to find, that the GPL ever actually made it to court was in Germany. In 2006, there's a guy called Harald Welter who founded a website called gplviolations.org, and he took D-Link to court. And he sued them, saying, I wrote code that's in the Linux kernel. D-Link has got a network-attached storage device that runs the GNU Linux operating system. They've stole my code. They didn't follow the rules. I want to take them to court. They went all the way to the Frankfurt District Court, and a judge said, yes, they broke the rules. Yes, the GPL is legally binding in Germany. Now, I don't know what happened after that, because I don't think D-Link got shut down or anything based on that. But that established, a legal precedent that at least in Germany, the GPL is a legally binding document. Now, in the late 90s, this is all hypothetical. None of this has happened yet. But it's pretty obvious if you read the licenses that it is going to. And in 2001, Steve Ballmer made this famous observation. that Linux is a cancer that attaches itself in an intellectual property sense to everything it touches. That's the way the license works. Now, Steve is wrong about Linux, he's wrong about the license, he's also wrong about cancer. That is not how any of these things work on any level, but it didn't matter. It's the CEO of Microsoft saying Linux is a cancer. This gets picked up by all kinds of things. Now, Microsoft in the late 1990s, they dominated business desktop computing. Their bread and butter was Windows and Microsoft Office and things like Exchange and Outlook, and they were terrified of anything that might represent a threat to that dominance. They have done a dramatic about-face in the intervening 25 years, and the reason for that is cloud, because cloud changed everything. Cloud unlocked a new way of charging people for software. Yeah, have the software, have the source, we don't care. You're going to give us money every time you run it, and we are going to make a fortune on this thing. Now, cloud works because it enabled economies of scale we'd never seen before. When I was a webmaster, one of the things I used to do was build servers. You come to me like, hey, we need a web server. Yeah, I could do that. I'd get it out of the box, and I'd put on Apache and Linux and MySQL and PHP and all the other bits. It'd take about a day, £1,000 for the hardware and the setup, and then a couple of £100 a month maintenance. If I had 50 people all phone me in the morning going, hey, can I have a web server by lunchtime? Yeah, not a chance. I've just turned down 50 grand in income because it doesn't scale. So forget about building servers. Let's start building data centers. Let's start automating data centers and shipping container-sized deployable units of computing. And every single step, operating system, networking, we script, we configure all of that, and we get to a point where 50 people come to us and say, hey, can we have a MySQL database? We're like, yeah, just click the button. Boom, bang, bang, bang. And next thing you know, we are making $1 million a month from running MySQL, which is free software, in the cloud. Let me tell you folks the story of Sammy the squirrel. Sammy lives in the forest with all the other happy little woodland animals, and they frolic about, and they look for acorns, and they splash around in the stream. And on Sunday mornings, they go to the glade with the old tree stump, and they do woodland show and tell, and they all show each other what they've been working on. And Sammy likes to make computer games. And Sammy has written Acorn Adventure, which is lovely. You run around and you gather acorns for the winter and frolic with all the other animals. And the next week, the woodland animals gather for show and tell, and they notice that Jeff the raccoon is there. And Jeff has brought an arcade cabinet with real buttons and a screen and everything, and a little slot where you can put in 20 cents to have a go on the game. And this is amazing. Sammy's like, look at that, it's my game. It's running in a real arcade cabinet. This is awesome. And the game is brilliant, and the animals are lining up to play it, and they're putting coins into this, and the little animals are pestering their parents. Dad, can I have some more money so I can have another go on the game? And everyone's really excited about this, and the next week, Jeff turns up in a brand new pickup truck with 2 arcade machines. And some of the animals are starting to get a bit upset because the game is hard. They're like, level 2 is too difficult. This owl you've got to finish, defeat to get to the end of the level. We really don't like that. Also, the graphics, they could be better. And the music isn't really that good. Can you fix the music? And Sammy is saying, you can fix it. It's free software. You can send me a patch. But of course, to them, it's not free because they've been paying 20 cents every time they have a go. They think they're paying customers. They get a little bit upset about this. And the next week, Jeff turns up in a solid gold helicopter. But that doesn't matter. Sammy has been hard at work. Sammy has built Acorn Adventure 2. The owl is easier to defeat. The graphics are better. The music is better. The gameplay is better. Everything is improved. And Sammy has put a little clause in the license that says, if you want to take this and play it at home, that's fine. If you want to use this to learn about software, that's fine. If you want to run this on your pay-to-play arcade cabinet machine, you need to give me 20% of the proceeds. Oh boy, the woodland folk did not like that. Not one bit. Sammy's a traitor. Sammy's done a rug pull. Sammy has betrayed the principles of free software. One of them gets so angry, they take the source code for Acorn Adventure 1 and they fork it and they call it Open These Nuts. Now, how did we get here? Or maybe that's not what happened. Maybe around the time that all of the animals are getting angry about the graphics and the gameplay, Wilbur shows up. Wilbur the Weasel. And Wilbur says, hey, looks like you're having some trouble with your game there, friend. I can help you out with this, and contributes a couple of gameplay fixes, the odd bug fix. Wilbur is prolific. After a couple of weeks, Sammy's lost track of how much code Wilbur's contributed, but that's all right. you know, Wilbur is adding features people want. Something everyone's been asking for is, hey, can we pay with a credit card so we don't have to keep bringing bags of 20-cent coins? So Wilbur adds credit card payment to Acorn Adventure. And then somebody notices that every time someone puts their MasterCard into Acorn Adventure, it's sending a copy of it to a server in Belarus. And they turn around, and at this point, Wilbur's not there anymore. And now you come to think of it, no one really knew who Wilbur was. No one's seen Wilbur around before, and all the other angry animals who were shouting at Sammy because the game wasn't good enough, they've mysteriously disappeared as well. Now, this is a situation that we are seeing unfold time and time and time again. We have trillion-dollar corporations out there who make a significant amount of revenue from providing access to free software. Now, the GNU folks, or the Free Software Foundation folks, they wised up to this possibility a long time ago. In 2002, they created a thing called the Affero GPL. Affero was the name of a company who were building web applications, who were very, very kind of keen on this idea of free and open software. And the Affero GPL, the GNU public, or the GNU GPL, General Public License, that says if you distribute your software, you have to distribute source code. So if I give you a copy of my program, I have to give you the code as well. And if you give that copy to someone else, you have to give them code as well. But just interacting with it across the network doesn't constitute distribution. If I open my phone and I load up, I don't know, TikTok or whatever, they're not actually giving me a copy of TikTok. I'm just interacting with it. The Affero GPL says, well, actually, even if you're just interacting over a network, that constitutes distribution. You have to give your source code to anybody who has interacted with your application. Now, within the last couple of years, we've seen tools like Copilot and Bard and Grok and AI assistants and machine learning language models. More and more developers are using these tools to make them more productive. And these tools have been trained on publicly available source code, which I am absolutely certain includes code that was published under the Affero GPL. So if somebody at TikTok, Netflix, Warcraft, working on any of these platforms, they get a bit stuck one day, and they go onto Copilot, and they get a solution, and that solution happens to include some lines of code which are identical to software released under the Affero GPL. That code makes it into production, it goes live. From that point forward, legally, everybody who opens TikTok is entitled to a copy of TikTok's entire source code. If you accept that Copilot has copied the code. If you say Copilot just accidentally ended up at the same solution based on all of its training data, then that's a different set of circumstances. Now, I'm sure a lot of lawyers are going to get really, really rich figuring this one out over the next couple of years. For now, it's just this sort of weird hypothetical question, but I'm betting that, Stallman and the Free Software Foundation, their eyes are lighting up at the prospect of being able to take someone like TikTok to court and sue them and get them to publish their source under the Affero GPL. The thing is, most software these days is not published under the GPL or any variant of it. It's published under one of these, the permissive licenses. Now, I am not an intellectual property lawyer, I am not a software licensing expert, and I am not your software licensing expert. If you're going to make any important decisions based on any of the stuff in this talk, you need to hire somebody to tell you what applies to your business in your jurisdiction. But very broadly speaking, the way these kind of licenses work, so the MIT license, which is one of the most popular ones, it's short. This is the whole thing. And this basically boils down to, we own the software, do anything you like, you can't remove the license, and you can't sue us if this software doesn't work. And most software published under permissive licenses, I mentioned earlier, it's governed by a thing called a contributor license agreement. If you want to contribute code to React or any of the Meta, Facebook open source projects, you've got to go on here and you've got to sign a thing saying, yeah, I understand this is my code and I'm giving it to you. And what this gives them the right to do, if Facebook turn around and they go, you know what? React ain't going to be free anymore. React 20 is going to cost $50,000. They are legally allowed to do that because even though you wrote that code, you have signed away your rights as the author by signing that contributor license agreement. You wrote it, but you don't own it. They own it. And they make it free because they choose to, probably because their lawyers and accountants have said, yeah, make it free, it looks good, and we might make more money if people think we're nice. If they decide to turn around and revoke that access, you have no right to complain about that because you have signed away your ownership of that property. So Why do we do this? Why do people do hard work in their own time and then sign a license agreement that conveys ownership of that work to somebody who isn't paying them? Well, in some cases, they do it because they are paying them. A significant amount of the .NET code base is written by people whose job is to write free software at Microsoft. They get a salary, they get money, they get corporate support, they get all the things, and Microsoft decides that their work will be published under the MIT license, which governs that. Sometimes they don't care. Sometimes it's just share code, have fun. That's it, the end. They don't care about profit. They don't care about outcome. There's a lot of folks out there who love writing software, and they're financially secure, and this is just a nice way of enjoying their weekends. They put stuff out there. Yeah, no big deal if we don't get paid for it. But a lot of folks, they have this idea, like, I'll write the code, and I'll publish the code, and everyone will see what a good programmer I am. They'll see the quality of my work, and then they'll buy a support contract, or I'll get consultancy gigs off the back of this, or maybe one of these companies will turn around and hire me. And this happens sometimes. There are lots of people who have made, financial success stories that started with them writing free software, but there's also a lot of Sammy Squirrel developers out there, sitting there wondering why they don't have enough acorns for the winter while Jeff flies around in his solid gold helicopter. Within the last couple of years, we've seen some very high-profile projects turn around and change their licensing. The most recent one was Redis. Redis is about 15 years old now, and until March this year, Redis was published under the Berkeley Systems Distribution License. It's a permissive license, like the MIT license. We own the software, do whatever you like with it, can't sue us if it doesn't work, and you can't change the license. Then, in March this year, they turned around and said, we're not doing that anymore. We're changing the licensing. And they went so far as to explicitly say that if your business is offering paid hosted Redis in the cloud, you are not allowed to do that without paying for a license for Redis. This upset a lot of people. Within a couple of days of the announcement, Microsoft had announced a project called Garnet, which is a C# re-implementation of the Redis protocol, so you can drop that as a replacement if you're on Azure. A project called Valkey. Valkey took the last BSD licensed copy of Redis and went, we're going to make a new project. It's basically take the same Redis code base, we're going to spin that out into something that is still going to be free, and you can still run in the cloud. Now, we've seen a couple of different things do this. Unity did this recently, Terraform did this recently, Docker did this recently. Sizable companies who are like, we are no longer comfortable with the economics of using permissive licensing for our software. So what's going to happen? What is going to happen to projects like Valkey and so Terraform, the group that spun that off called it Open Tofu? What's going to happen to those in a couple of years? Well, at the moment, we don't know. But this is not a new idea. Some of you may have heard of a project called Service Stack. Service Stack, about 10 years ago, I used Service Stack for everything. It was excellent. It's a framework and set of libraries for building APIs and message-driven applications on the .NET stack. And back in the days when .NET kind of sucked, Service Stack was one of the things that made it kind of not suck. It's really, really good. And 10 years ago, 2014, Demis Bellart, who was the creator and maintainer of Service Stack, changed the license, turned around and said, this can't be free anymore. If this is going to be a good product, people need to pay to use it. And the community kind of splintered. About a third of them went, yeah, all right, fair enough, this is pretty good, we're going to pay for it. Some of them, and this includes me, we couldn't win that argument. I went to my boss, I was like, that thing we're using to build APIs? Well, it was free, but now it's going to cost $1,000 per developer per year. And my boss said, what's an API? Is it worth $8,000 a year? I was like, not to this company right now. And so we switched. We switched to using something else for it. But a couple of people spun up an open source fork. They called it NService Kit. They took the last snapshot of the free code base and turned that into a different project. Now, I emailed Demis last month, and I basically said, look, I'm doing this talk in Oslo about open source and free software and everything. How's it going? How did it work out? And he got back to me, and he said a couple of things I thought were interesting. He said, I've been able to work full-time on Service Stack. So he used to work at Stack Exchange. That's the day job that he left to go and do this. Service Stack has greatly improved. It's much more capable than would have been possible as an open-source side project. He said, I was willing to take a pay cut to be able to work on my own project. I was pleasantly surprised when it ended up making more money than any job I had had prior. Service Stack has allowed our family to be financially independent and given me the freedom to work on whichever features I want. Financial independence, work on whatever features you want. Hands up if that sounds like a pretty good way to live your life, yeah? We can get behind that. Now, Service Stack has gone from strength to strength. The license shift was version 4. That was 10 years ago. Service Stack has just shipped version 8. They've got plugins for all kinds of things. They've got Angular components. They've got message passing. This is a really solid, mature, and from what Demis is saying, a financially sustainable library now, thanks to pulling the rug and saying it's not free anymore. If you're using this and you're using it in a corporate environment, you're going to have to pay us for it. So what happened to End Service Kit? Well, there was about a year of lots of very enthusiastic, software should be free, let's do this, they can't do this to us. Here is the GitHub repository for End Service Kit. The last commit on that was 9 years ago. It's kind of fallen by the wayside. No one is really using that very much anymore. Because what happens is when you fork one of these projects and set up a free version, give it a couple of years, and you have the same problems that caused them to do the thing they did in the first place. You have more users, which means you have more issues, which means you have more requests, more support, more overhead, more maintenance. And unless that translates into more resources that you can use to find hours in the day and smart people to fix those problems, it's not going to work. It's not going to scale. And Wilbur? Wilbur's not actually a weasel. Well, for all we know, Wilbur is actually a weasel. But this is the contributor dashboard for a project called XZUtils. XZUtils is part of the OpenSSH login system, which is used to get remote access to just about every Unix and Linux system on this planet. Now, this is the number of people who maintain this vital piece of internet infrastructure. The number one contributor is Laju, Lasse Collin, 1,945 commits over about a 20-year period. The number two contributor is someone called Jia Tan. We don't know who Jia Tan is. Jia Tan might actually be a weasel. Jia Tan might be a nation-state actor. Jia Tan might be an organized crime group. Jia Tan might be a 14-year-old kid in their mother's basement. We don't know. The third most active contributor to this vital piece of infinite infrastructure is the same Sam, who made 15 commits last year, and the fourth most active is Adrian N., who made 4 commits back in 2014. A tremendous amount of pressure and responsibility fell on one single individual to maintain a key piece of internet security infrastructure. Now, you look at this timeline here. Around this point, a lot of people on the XZUtils mailing list start being very, very aggressive about the fact that it is taking so long to merge patches and accept contributions and fix bugs. And this is the point where Jia Tan shows up out of nowhere and says, hey, I can help. I can do this. Let me help out, and gradually begins to establish credibility within this development community to the point where they have commit access, the point where they can push production releases, they can modify the build process, to the point where they came this close to smuggling a backdoor into XZUtils that we only found out about by mistake. A guy called Andreas Fraund, he's a Microsoft developer. He discovered this because he was doing some benchmark profiling, and so was trying to quieten down every process on his system to the point where nothing was using CPU apart from the thing he was looking at. And he noticed that the login daemon was using more cycles than it should. And he got curious, and he went sniffing, and he discovered an incredibly sophisticated supply chain attack that had smuggled a backdoor into the pre-release version of XZUtils that was running on his machine. Now, the engineering that got this attack this close to going into the wild was unbelievably sophisticated, you know, concealing things, binaries that didn't match the signed source that they were supposed to have been built from. But the foothold that got it going in the first place was social engineering. And it was social engineering created by the fact that the project maintainer was being harassed. They were being put under a huge amount of pressure, which makes them vulnerable to manipulation. Now, I'm absolutely certain that given enough time, all of you folks in this room, you would find really interesting, important projects to work on, and you would do good work, and you would produce good software, and the world would be a better place. But that is not how the world works, because we don't have an infinite amount of time. Time is money. Capitalism runs on money. There is this pressure to get stuff done quickly, to not spend any money that you don't have to. And it is really difficult if you have created something and shared it for free to turn around afterwards and go, actually, it's not free anymore. I'm really sorry. It seemed like a good idea, but now I actually have bills to pay. And so we keep seeing this situation. Somebody creates something, they put it out in the world for free. They do this, out of benevolence or curiosity, or they just want to show people what they did. And then they turn around and go, actually, if you're using this to run your business, can you give us some money? And everyone gets very upset. And so you did a nice thing and you made it free, and now everybody hates you. Now, I'm going to say what is possibly the most important thing in this entire talk, and I want you all to remember this, and I want you to tweet this, and I want you to tell your friends this, and I want you to tattoo this on the inside of your eyes so that you see it every time you blink. People who share their source code do not owe you anything. If I give you the source to one of my projects, I've given you the source and the freedom to use it. You don't get an upgrade. You don't get support. You don't get bug fixes. You don't get maintenance. You don't get dibs on my email or my time or any of that kind of thing. If you need access to that ongoing, it is your responsibility to keep a copy of it somewhere, because I might not even have the source code online tomorrow. People who publish their code, they give you the code, they give you the freedom to use it. If you need support, pay for it. If you need maintenance, pay for it. If you need stable builds, set those things up yourselves. Get a support contract. Hire somebody to run this thing for you. Do not think that just because somebody has put something on the internet and shared it with the world, that means that they have entered into some kind of obligation to support it and run it and maintain it and upgrade it and give you the next version. You don't get any of that stuff. And the amazing thing is that the source code and the freedom to run it for whatever you want, there's people out there for whom that is not enough. I use Adobe Creative Cloud a lot. I use it for all my videos. I use it for Photoshop and illustration and design, all that kind of stuff. I don't have the source code to any of those applications. I will never have the source code to any of that. I pay $50 a month to run Creative Cloud. If Adobe turn around tomorrow and go, yeah, you know what, 500, I've got to choose. Am I going to go 500 or am I going to lose access to the last 10 years of my own work? If they turn around tomorrow and go, oops, we bankrupt now, sorry, no more authentication servers, that's it. Game over. No more Creative Cloud for anybody. If, Adobe turn around and I discover a bug in Photoshop or After Effects, which happens about once a month, I can't fix it. I can't find it. I can't send them a patch. I can't do anything about it except file a support request and wait a week for somebody to turn around and go, yeah, well, actually, nobody cares. Sorry. Maybe try turning it off and on again. This is the alternative, And there's people out there going, well, that's your own fault. That's your own fault for using proprietary software. You should be using open source software for everything. Open source software is great. It is nowhere close. If you go online and say, hey, what's an open source alternative to Adobe Premiere and After Effects? People say, oh, you should use Blender and the GIMP. No. Blender and the GIMP is a 1970s cop show that never got made. Now, I love the ethos behind the Free Software Foundation. I love that the GNU Linux operating system exists in the world, and it is out there, and it is powerful and mature and capable and free, and no one can ever take that away. But we have this huge gap. Because over here, we have the fundamentalist ideology of the GNU project and the Free Software Foundation. And over here, we have Adobe going $50 a month, and you're never getting the source code, not even over our dead bodies. And there's this gulf in the middle that we have been trying to figure out. And I think what we're seeing at the moment, the last couple of years, is the free money is gone. The economies are tanking all over the world. Interest rates are going up. When there was free money sloshing around, yeah, let's give code away for free. It's great. It's awesome. We can always get another job. Life has got harder for everybody. And whether you're a CTO sitting there, CEO, looking at the line must go up thing and thinking, how am I going to explain this to the shareholders? Or you're standing in a grocery store going, when did cheese get so expensive? Everyone is thinking, hang on, there's still all this money sloshing around. Maybe we should be getting our share. And on that note, I want to leave you today with something to go away and think about. Within my lifetime, music has seen a fundamental shift in the way that it is distributed. From buying vinyl, to buying cassettes, to buying compact discs, to Napster and illegal downloads, to legal paid MP3s from the iTunes store, to streaming. Streaming dominates music today. Most people who listen to music do it on something like Spotify. And you know why Spotify wins? Spotify wins because it's convenient. You don't own anything. $15 a month to Spotify for the last 5 years, and I own no music as a result of giving them all that money. But I don't care, because I can listen to whatever I want, whenever I want. I just go, yeah, Taylor Swift, new album, bang, go. Oh, yeah, that's awesome. Do you know why the cloud works? The cloud is convenience. The cloud is Spotify for corporate IT infrastructure. We want the new Taylor Swift album now, except it's not Tay, it's a 64-bit PostgreSQL cluster. Boom, click, MasterCard in, there you go, you've got the thing you want. When you've finished using your 64-core PostgreSQL cluster, you can't sell it. It's not how it works, you're renting it. You have to give it back when you're finished. You own nothing. But companies use cloud because convenience wins. Now, if you've ever tried to get money out of a big corporation, by asking them to sponsor your open source project or to buy a support contract or anything. It's impossible, right? Like, no, big companies, you cannot get close to their money. You cannot get them to open their wallets. It's impossible, even if you work there. I've been to bosses and been like, we should really donate to this project. And they're like, why? We've already got the thing. Why would we give them money for something we've already got? But let me ask you another question. Are you folks out there who your company hosts on Azure or Google Cloud or Amazon Web Services? Do you actually know what's on your bill at the end of the month? If we stick another $10 on there, would you notice? Another 20? Another 50? 500? You know, depends on the size of the company. Now, we're going to use NuGet as a worked example here because NuGet is an ecosystem I know very well, and I'm very familiar with a lot of the packages and the kind of people who create them on there. We're going to do an experiment. We are going to create NuGet Premium, and we're going to see how the numbers for that thing work out. Now, let's say you want to get a package from NuGet. You got a choice. You can download it. You can compile it yourself, get it from GitHub, compile it yourself, build it, run it, effort. You can use the free tier. Yeah, that's fine. That gets you 20 packages a day. If you're running a big corporation, you're running continuous delivery integration servers, you're going to burn through your 20 downloads a day pretty quick. And at that point, we're going to give you a choice. You can go back to GitHub and build it yourself. That's always going to be there. The source code is still free. You can add it to your cloud bill. Now, this is going to mean meetings. This is going to mean talking to GitHub and talking to Amazon and talking to Circle CI. But, you know, the best way to make a successful company is not to send lots of little invoices. It's to get people like Microsoft and GitHub on board and send them one invoice every month for $750,000. We can get that set up. That's beautiful. And we give them whatever metadata they need to pass that on to their own customers. So it shows up on your cloud bill, and that just gets paid because no one really knows what that stuff is for anyway. Or you can pay for it. Same way folks pay for Spotify. Now, let's crunch some numbers here. NuGet, they don't publish total download figures, but they do publish their 100 most popular packages with the downloads over the last 6 weeks. So we can take that, we can plot that on a graph, we can apply a trend line to that graph. Now, we're going to use something here. If any of you folks know what integral calculus is, that's what this is. If you don't, let's just pretend we did this by magic, all right? I want to know how many packages get downloaded from NuGet, and that means that we need to figure out what is the area underneath that curve. That'll give us the total number of package downloads, so we want to integrate that curve. Now, this number here, that is the total number of packages on NuGet, including the ones that haven't been updated, like NService Kit, in 9 years. I don't think we want to reward those people, because we want to incentivize active maintenance of open source projects. So I was like, well, how many packages are there on NuGet that have been updated within the last year? That number was hard to get. If you want to know how, there's a link at the end which links to the source code, which downloads the entire NuGet catalog, puts it into a SQL database, and crunches it. The number that I managed to come up with using that was 138,000. So that many actively maintained packages on NuGet right now. So we just need to do that integral. Now, I could do this when I was 16. I'm not 16 anymore. I've lost a lot of brain cells since then. Fortunately, we have Wolfram Alpha. So you can go over here, and we can say, I want the integral between 1 and 138,000 of 1 times 10 to the 8 over the minus 0.533, and we get that number, 53,767,000 NuGet downloads. Remember that next time someone on Hacker News says that .NET is dead and nobody uses it, right? That's like 8 downloads per human being on this planet every 6 weeks. Now, how many people use NuGet? This one I had to fudge. I couldn't get any accurate data on this from anywhere, so I made an estimate. I crunched the total number of downloads of the most popular package, which is newtonsoft.json. That gave me a sum, 142 million downloads in 6 weeks. And I looked at my own work that I've been doing for the last couple of months, and I assumed I'm average, because obviously I'm a very average person. 10 Newtonsoft JSONs per week for me, so I crunched that number in. 2,374,000 users. Let's do some Bart Simpson blackboard arithmetic. So we got that many downloads every 6 weeks. That's roughly that many downloads per month. We've knocked a little bit off there so that we can take some commission to run our own infrastructure. that many billion or million active users, set up a pricing plan. Half our users are free. Because half of Spotify's users are free, that seems like a good place to start. We got that many people on the $15 a month basic plan. We've got that many people paying $75 a month for indie. And we got a couple of big corporates paying $500 a month. That gives us this revenue pot, $43 million a month that we can distribute to the package authors who are creating the free software that makes our service function, which works out at $0.001 per download. Now, if any of you know how Spotify's business model works, one, you'll know Spotify are notoriously stingy and tight-fisted, and two, Spotify pay a lot more than that. But from where we are with open source, even Spotify would be a massive step in the right direction. Now, what this works out at, Automapper, Mock, you know, the really big, popular top 100 packages, they're talking about $13,000 a month. Now, we are not talking here about buying licenses. We're talking about a convenience fee for binary packages. This is just like a way of maybe moving the needle in the right direction in terms of our industry's attitude to paying for open source and getting paid for it. Middle of the road, projects like Image Sharp, bringing about $3,000 a month. Now, that's not quit your day job money in most places on this planet, but it is, hey, boss, I'm going to go 4 days a week for the next couple of months because I want to take some time to work on the new release. And way down in kind of the long tail, N-Audio, $120 a month. Now, N-Audio is not a massively popular package. It's an excellent package, but there's not a lot of folks doing big business with audio on .NET. So Mark Heath, who makes N-Audio, yeah, he's got a summer holiday or maybe a new developer laptop every couple of years. Now, you know, this is not a business plan. This is an experiment. This is, do these numbers come out in the right kind of ballpark? And I kind of think they do. But this is never going to happen, right? Because NuGet is not going to turn around, NPM, pip, Maven, none of these package repositories is going to turn around and make something paid, and people will recoil in horror at this. You know, the winning move in capitalism when you find a free resource, you don't reward it, you exploit it, because that's how line got to go up, and if line stopped going up and you have to explain it to the shareholders, things get uncomfortable. But the idea of paying for convenience has been established. The idea of selling free software has been around for as long as CD-ROMs have existed. That has been there the whole time. Now, if any of these platforms did turn around and go, you know what, the free lunch is finished, the Woodland folk are going to riot. But the last thing I want to leave you with, it doesn't have to be one we've already got. Something interesting is happening in our industry right now. If any of you has seen talks that Steve Sanderson has done at NDC within the last year or so, Steve is talking about WASI, the Web Assembly Systems Interface. This is a way of distributing packages that can talk to each other even if they were built with different languages. If I want to build an application, and there's a calculation engine here that was built in Haskell, and there's a view engine over here that was built in .NET, in C#, and there's maybe some kind of email rendering platform here that was built in Go, I can pull down those packages and I can combine them. And this means that within a year, maybe 2 years, we'll have a point where if you want to encode PNG images, there is one package that does that you can download. And it doesn't matter what you're using, Python, Go, JavaScript, Rust. That's the package you are going to use, which means there is going to be a marketplace. There is going to be a repository of WASI packages. And so before we all rush headlong into, yay, free, let's make all the WASI packages free, and then 2 years later everyone is burned out and exhausted, and Jeff is flying around in another solid gold helicopter, maybe WASI is a chance to do something new and to approach it differently. You know, open source is 25 years old. We've done free as in beer, and it's awesome. And there are people all over this planet who are running software they didn't have to pay for. Students, hobbyists, startups, curious people, tinkerers, free trials, experiments, all this stuff. It is fantastic, but if you're making $1 million a year off other people's free software, I think it's time we encourage people to give some of that stuff back. We've done free as in speech. And that's awesome. And we have this free enterprise-grade operating system out there that nobody can take away, supported by a growing body of legal precedent that says the GPL is binding and no one can take that freedom from us. But the freedom comes at a cost. You know, it is frightening how much of the internet relies on one person working evenings and weekends, and it is terrifying the abuse and hostility that those people encounter when they try and claw some of that back. So I want you to think about a third kind of freedom. I want you to think about waking up on a Saturday and going, I got a free weekend. I'm not going to get emails hassling me about stuff. I'm not going to get my boss WhatsApping me going, we think there might be a backdoor in our login system. I want you to think about waking up and going, you know what, I can relax. I'm financially secure. I can pay my rent. My projects are doing okay. No one is hassling me right now. I'm going to take off. I'm going to go out, drop away, get off the grid for a couple of days, and I'm not going to worry about what's waiting for me when I come back. Free beer and free speech are all very well, but a free weekend, I'd pay for that. Thank you. So folks, hit that URL, all the source, all the sources, all the calculations, all the calculus, all the source code, everything went into this talk is out there. And if you like that, come and chat to me. I'm around all week. I'd be really interested to hear perspectives on whether you think something like this might work and whether we could actually turn this into a thing. Thanks for coming, folks. Have an awesome couple of days. Enjoy the rest of NDC. I'll see you around.
Okay. Shall we get started then? Audio's okay? Okay, great. I think we're ready to start then. Good. And we've probably got a lot to cover, so I'm going to dive straight in. So let's get moving. So functional programming on .NET, the best of both worlds. Right. So that's me. My name's Isaac Abraham. I'm a consultant in the UK. I spent a few years in Germany, but I'm primarily from the UK. I run a consultancy called Compositional IT. We do F# consulting, .NET, Azure. I've basically been working in .NET since .NET 1.0. I don't even want to think about how long ago that was, but since the very beginning, since Visual Studio 7, I think it was. And I spent probably 10, 15 years in the C# world exclusively, and then I've moved on to F#, and I still sort of dabble a bit in C#. Before I sort of go too much further, I just want to get an idea of who I'm talking to, which will help me sort of understand where I should emphasize and not. So just a quick show of hands. How many here of you today are doing C# today? Okay. Excellent. How many of you would say you're doing modern C#? And by that I mean C#, double digits, 10, 11, link. You're allowed to use var. You're allowed to use link. The drill. Is there anyone here doing F#? All right. That's the 12 of us in the whole world, right? And how many of you have got any experience in any functional language, whether it's Elm, Haskell, Scala, something like this? Okay, good. Okay, so what I really want to do today is to address like the why. Why should I be interested in functional programming? If anyone here saw Mads Torgerson's talk from like a week ago, it was on YouTube from NDC Sydney. That kind of, it's not going to hurt if you've watched that or if you watch that after this, but it's not going to be the same sort of content. But I really want to talk about what is FP really? What is it at its heart? How can we start to use it in C# if we wanted to? And should you even be trying to do functional programming today in C#? And what those limitations are. So I think there's quite a lot of misunderstanding about what is functional programming today, particularly in the .NET world. And I think it's led to functional programming having a kind of reputation as being hard. Maybe it's for maths and science. It's not for general purpose programming. Or at best, there's kind of a belief that, well, functional programming is cool. It's really interesting, but it's too hard to learn, or it's ugly, there's loads of generic arguments, and why would I want to do this sort of thing in C#? And my aim today is to kind of dispel that and show you that actually you don't necessarily have to give up the good things about being productive, good tooling, .NET, but also let you benefit from functional programming techniques. What do I mean by like simple F# though, and functional programming, I guess? Has anyone seen this diagram before? It's like a journey that many of us have taken, I think, and I put myself in that category, where I started doing fairly simple code when I got out of uni. I didn't really know what I was doing. And then I got these books like Uncle Bob and Gang of Four and stuff like this on design patterns, and I sort of went crazy. And I started doing design patterns everywhere, and it got super complicated. And then I ended up going back to fairly simple code with just a few patterns and not much more. And I think when people think about F# and functional programming, we think of this bit in the middle here with things like applicatives and monads and category theory, all these things that no one really wants to do and gets scared of. And I want to sort of ignore all of that. Forget about all of that. Just think about simple things like functions, data, and types. Really not much more than that. So fairly simple concepts that you guys already know and how we can use those. There will be no talk about hard FP concepts today, none of that. So just the why, and I'm going to do this very briefly, and I'm talking from a perspective of having done functional programming for probably 10 years on .NET now. And it's pretty simple. Lower total cost of ownership, less bugs, happier developers, and improved time to market. It really is that simple, and it does work. But don't just take my word for it. Look at this phrase here. So when it comes to cloud programming, history is on the side of FP. I'm sorry, object-oriented programming is just not good for that. Simon Peyton-Jones, Eric Meyer, or Don Syme. Who said this? And that's right. It was actually Mads Torgersen, the C# program manager. So when I say this, this is not controversial. And if you look at the direction C# is going, it's getting more and more of these pseudo-functional features in the language. But why would he be saying that? What does he really mean when he says that? So I think it's worth just spending a few minutes talking about what actually functional programming is. And I think this is really the crux of it. We have all these sorts of terms that you may have heard of, lambda functions, extension methods, pattern matching, records. These are things that have come into C# in the last few versions. Lambdas have been there a bit longer. And then we've got other features that may be coming in the future, things like tagged unions, and maybe pure functions and curried functions. The truth is, in my opinion, none of that matters. None of these technologies or tools or terms actually really are about functional programming, really. Functional programming for humans is really just two things: expressions and immutability. And if you can get your head around those two, and they're really not hard, then you understand functional programming, and you can see how to use it in C# today. If you do those things and stick to these two rules, then you can start worrying about other things, like composition with functions and simple code and separation of data and behavior. But those kind of things come because of these two things on the left. So I'm just going to talk about what they are. Who here understands and says they're confident they know what an expression is in C#? Pretty much what I thought. And it's actually really simple. If you look on docs.microsoft.com, it's got this huge article that I didn't understand any of it when I looked at it last week. It's got things called expression statements and all sorts of crazy stuff. And I was like, I don't understand this. Let's find a simpler way of defining what expressions are. So this is all an expression is. Whenever you see that word expression, this is all it means. It's a block of code that you can assign to something. So ask yourself this question: can it be assigned? Is there a left-hand side of an equals? If it is, it's an expression. Congratulations. Oh. OK, we're on. So here are some examples. So add is a function. It takes in some data, and it's going to return you an answer. That's an expression. That's an expression, equality. It's got something assignable to the left-hand side. It's got a result. This is our friend the ternary operator. It also can be assigned to the left-hand side. Switch expressions, for those modern C# devs, you'll know what this is. Again, that's giving you a result on the left-hand side that's either yes or no. On the other hand, we've got statements. And essentially, anything that's not an expression, that doesn't fall into that category of can it be assigned to the left-hand side, that's what I would call a statement. So it's a block of code that has no result. So the sorts of things I'm thinking of are, does it return void? Does it have a result? Can you assign it? Or does it have some assignment in the middle of it? If it is, it's probably a statement. So add and print here. That's a statement, in effect, or a procedure. It's returning void. You can't assign it to anything. Console write line is also really a statement. Can't be assigned. It has no result. For each loops, switch case statements, if statements, they're all statements. They have no result. Why am I sort of making a point about these two things? It's because expressions are much, much easier to work with. You can understand them better. They're safer. You get less bugs when you use them. They're simpler to test. Usually, they're easier to reuse and compose together. So I would always say, like, this is a really core part of functional programming, is this idea of something goes in, you do some operation, and you get something back out. What you do with it is up to the caller. It's not about the implementation. And I've just put together a really simple example of it's a bit of a straw man, but hopefully you can see what I'm talking about here. So this is some code that will basically take in a customer, and it's going to look at the status of the customer, their logged in state. And if they're logged in, we're going to set the name to Fred. Otherwise, we're going to set it to someone. And then at the very bottom, we're going to print out, hello, Fred. But there are a couple of ways that this could go wrong. And this is really simple code. And you may look at it and think, I would never do this. But obviously, we have to start by assigning name to null. Now, if we were to remove this branch, this code would still compile. The compiler has no idea that you're doing something wrong. You've missed out a branch, and it will just happily go ahead and print hello null. Now, the compiler may warn you that you've got this potential unassignment, but it will still compile. It's still going to work fine. You could also do something like that and assign accidentally to the wrong variable. Again, the compiler has no idea what you're really trying to do is to guarantee I want to assign something to name. If you did this as an expression, that whole thing goes away. So I'm using a switch expression here. And here we've got this notion of, like, if it's logged in, return Fred, otherwise return someone. But the result of that entire expression goes into name. So just by moving to this notion of expressions, we've removed these possible bugs and classes of bugs. And obviously, it's a very simple example here. But this idea of telling the compiler we want to do some logic and assign the result into something else is quite powerful. And if you use this everywhere, entire sort of issues that you face will just vanish in terms of accidentally assigning, refactoring, and so on. So that's kind of the first thing. The other one is immutability. Again, I looked on docsmicrosoft.com. I found one article about immutability that started talking about entity framework. So I skipped that out. This is all immutability means. Something can never change. You create some data, and its value is fixed for life. That's it. If you want to do a change, you make a copy of the data, and then the copy has the changes. So simple test, is all the data read-only? If it is, this thing is immutable. If it's not, it's not. So why would we want to do immutability? And it's the same sort of thing. Code is easier to reason about with immutability. You don't have to worry. For example, if you've got an object, you can give it to someone else, some other part of code. You don't have to worry about it changing behind your back. The value is fixed for life. You can decouple it much more easily because, for example, if data is immutable, you can probably make it public. And if it's public, you can probably write functions that deal with this data much more easily than you would if it's all encapsulated in a private class. Multi-threading definitely is a benefit because you have no shared mutable state, so you don't have locking or any sort of race conditions to worry about. You have data, anyone can read from it as often as you want. If anyone is worrying that what I'm talking about means your entire app has to be immutable, the answer is no. There will always be some mutable state in your application. The important thing is that it should be fairly closely scoped, small scope, and the exception to the rule, rather than what we have today where most data is mutable and you might have immutable data now and again. If anyone's seen these kind of architectures like hexagonal and onion, they all basically are talking about this. Mutable state on the edges of your app, and then immutable state in the middle. That's it. We're 15 minutes in, you've now learned functional programming. That is really all there is to it. Expressions, everything should have a result, and immutability. Everything is fixed for life. If you can follow those two simple rules, you're basically doing functional programming. The challenge is that those two things are actually somewhat difficult to do consistently in C#. I want to take a little step back now and just talk about what that might look like at a higher level in terms of how we compose code, how we build blocks together. So these are the sorts of things you will probably avoid if you're trying to do functional programming today, like class hierarchies, inheritance. That's basically out. Instead, you would probably look at static classes, static methods. Interfaces, maybe, but instead, you're going to prefer functions, just standalone functions that you plug together. Instead of stateful objects, pure functions, and this last one is actually quite important. You probably will move away from constructor injection and just have arguments into functions. That is it. There's no other way of sort of injecting state into a function. You just have normal function arguments. And that kind of leads to separation of behavior and data. So instead of having a class that has data in it and then methods that act on the data, we've got data on one side and functions on the other. And the functions take in some data and they return some other data. But they live independently, they operate independently. And this is really what Mads was talking about in his talk last year, with this idea of having data that's coming from some source and then the ability to abstract over it in many different ways. An example of how this might look. So this is a very simple calculator class, and I've written it in a kind of OOE style, should we say. So we've got some dependency injection here, because my calculator needs to log what it's doing. So I'm injecting an ilogger there, and I'm using the nice new simple constructor syntax in C#, which is very nice. And then down here, we're calling this logger.log method. So I've got this method on the type I'm calling. I've got some mutable state here, so I've got this value, and every time I call add, it's going to then mutate that state. So it's going to add whatever I've passed in and add it to the value. The thing that I don't like about this is the signature of add. It's kind of lying to us. It says, you give me a number, and I will give you back nothing. You can't see what it's doing behind the scenes. You need to look into the code to understand what it's doing. You don't know, just from looking at add, that it's calling logger. You have no idea that it's doing that either. So there's kind of a bit of magic going on here. What about testing? The same sort of thing. If we wanted to write a unit test for this function, you call this calculator and you pass in a logger. You don't know where it's used. You call add, but then you assert on a different thing completely. You assert against value. It's like you have to know, I called add, but that's going to modify this value property. And it's like there's kind of action at a distance, shall we say. If I was to do this in a kind of a more functional style, this is what I would probably look for. So instead of having an instance class, this would just be static. There is only one calculator. We don't need many of them. There's no constructor anymore. That's gone. And all my dependencies, all my arguments, are going into the method directly. So I've got the logger being passed in, and I've got the state, the value, coming in, as well as the value I want to add to it. Also here, you'll notice that logger is no longer a type. It's not a class. It's just a function that I've passed in. It's just an action. So this is kind of a bit like what we do with link when we're passing in functions. And instead of mutating, I just return the answer. It's up to the caller to decide what to do with it. I'm not interested. And the function signature now is actually much more honest. I can now see that I'm returning an integer, and these are the things that this function depends upon. There's no kind of magic there. Testing it is also much, much easier now. Yeah. I can explicitly see this is the log function that I depend on. I don't depend on just this entire logger type, and I know it's being called from within add because it's needed. And there's no internal state. I simply get back an answer, and I can assert that. So there's no magic going on or anything like that. And this kind of principle of simplicity of just I call something, I see what it needs, and I get back an answer, that's what we're really talking about here. So I want to come back now to all these other things we spoke about. Like I've not touched on any things like lambdas or records or tuples, and yet everyone is saying that like C# is functional now because it has these things. Like, how do those two things resolve? So if we Wonderful. Okay. We all good to carry on? There's no nuclear threat. Okay, so let's go back there. So, right. How do we resolve these things to what I've just been talking about for the last 20 minutes? So let's start with expressions and immutability at the bottom. Those are like fundamental pillars that I've just spoken about. Above that are things we want to do in an app. You know, defining types, reasoning about data, working with functions. And on top of that, we have all these nice features that C# has. Yeah, things like records and tuples, and pattern matching and lambdas. None of those are kind of fundamental to functional programming, really. All they are is syntactic sugar, most of them, that make your life easier to try and make use of these kind of things that I've shown you. Yeah, so instead of records and tuples, you could just use classes. But we all know that it's a pain to use classes to do like value objects, to do immutable data. That's what records are there to make life easier. But just because you're using records doesn't mean you're doing functional programming. Like, don't confuse the two. And I just want to focus on lambdas, particularly because everyone talks about lambda calculus and lambda expressions and functional blah, blah, blah. I just want to show you what I mean when I say that lambdas are not necessarily like a gateway to functional programming. This is a for loop that's going through some numbers and calling add and print. Is this bottom one more functional because I've changed it to use a lambda expression? No, it's exactly the same. Just because I happen to replace it with a lambda expression does not mean I'm doing functional programming now. It's exactly the same as the top one. The same way that if I'm using link, and I've got this select here, if I replace it with an anonymous method from C#2, does that mean this is less functional? To me, it's exactly the same code. It's just a slightly more complicated syntax. If I assign a lambda to a func and pass that in, it's exactly the same. And if I have a static method in a class, or even an instance method, it's no more or less functional. These are all exactly the same. Just because we're using a shorthand syntax doesn't make it functional programming. They are just syntactic sugar. They just make it easier to start working with functions. They don't do anything more than that. So just remember that. For those of you that are using link and that are allowed to use link, I just want to focus on why it is functional. Because if I was to ask, and I have done in the past, like, why is link functional? The first thing everyone says to me is lambda expressions. And the second thing they say is extension methods. But to be honest, that is, to my mind, those are not functional programming things as such. What's more important is that it's expression-oriented. Each of these stages in the pipeline is going to get some data, push it to another stage. That's going to get the data, push it to another stage. Yeah? These are all immutable collections. Yes, it's IEnumerable, but the idea is you've got one collection, that's then pushed into another one, which has a modification, which has another one. And each of these are independent from one another. You can change them, you can reorder them, nothing is going to break. We can compose functions together. So I've got select and I've got a square. And I can compose them to make a function called select squares. That's really what that's doing. And lastly, we've got this separation of data and behavior. So I've got numbers and then I've got my functions. But these functions don't live on numbers. They're not coupled to it. They're completely decoupled. Just as an exercise, I decided to see what would it look like if we had done link with objects instead of functions. And I'm just going to show you a couple of examples of what it might have been like. So for select, where we had our x goes to x before, you would probably need an interface, iSelectable. And if you wanted to do where, you would need an ifilterable interface. And then you'd probably have to implement each one of them every time you wanted. Is that me again? No? Okay. You'd probably have to do this every time you wanted another pipeline stage. You'd have to make a new class, implement this interface as a new type. And then you'd be passing them in everywhere. So we'd have select with a new square number operator and a new even number. So we're using things like decorator pattern and strategy pattern, and we've got parameterization via constructors again. It's all back to where we were, like in the C# 1 and 2 days. Let's go forward again. That's a good click. So just so you can see, like, that's the distinction that I'm getting at. It's not so much the lambda expressions that's important. So what would FP Lite look like? If we wanted to do FP in C# today, what sort of features would we be looking at? And this is really what I want to explore a little bit, is we would basically be focusing on, or I'm focusing on standard C# features. I don't want to use libraries like langxt or oneof or things like that. Just what is out of the box in C# today. Let's just use simple rules. We're going to focus on this core set of functional programming, just expressions and immutable data. What would that look like? And to do this, I would say let's take the approach that some other languages like F# take, which is let's split the language in two. And we're going to keep the bits of C# that are useful, and we're going to throw away the bits that are not useful for functional programming. And what's left, basically? So to me, what's not useful are things like mutable data, statements, inheritance, combining data and behavior, and like fire and forget. We want to get rid of all of that, and we want to focus on these things on the right. Yeah, immutability, expressions, composition, separation of data and behavior, and functions. Which really looks like this. You can't use instance classes anymore. You basically never use them. Void methods, not allowed. So you must always return something. Constructor parameters, out. Inheritance, out. Polymorphism, definitely out. So instead of that, you've got records for data, static methods for functions, function arguments, records for data, and pattern matching. That's basically how you would work together. The only type of inheritance you could use would be in very specific cases, where you want to show like a subtyping, but without any behavior. We'll come to whether or not I think that's a good thing or not to do, but this is what I would say, that if you wanted to do functional programming in C#, that's what it would probably look like. And if I was to go back to writing C# today, that was probably what I'd be doing. I probably wouldn't enjoy it very much. What is missing, though, from the language, and where might it be going next? Now, I can't speak for the C# team, but these are the sorts of things I would expect to see in the future. If C# is continuing down this journey of adding more functional features. So these would be things like union types. Has anyone heard of union types? Yeah, a few of you. OK, good. We'll go through a quick example of that. Probably exhaustive matching will come in as part of that, and maybe simpler composition. The things I think will be harder to get in C# will be immutability and expressions everywhere, because that basically is a breaking change. You can't break C#. So I think those two are probably off the table. And then curried functions, which is basically a way to compose and work with functions more easily, probably won't happen. And the same for this effect management. I don't think C# will get them. But let's focus on unions, because that one is probably coming in the next version of C#. So in OO today and in C# you can do AND very easily. You know, a customer has a name and an age and an address. And those are just fields. What you can't do very easily is model exclusion. A customer is this or this. They are creditworthy or they are a credit risk. It's not so easy to do that kind of thing. Today we would probably use inheritance for that. And that's really what unions are supposed to solve. So just to give you an example, let's say we had a customer we wanted to model in C#, and they've got a contact method. And the contact method is either email or post or telephone. But only one can be selected at any one time. And you need to be able to contact by them. So, I can either contact by email, contact by post, or contact by telephone. I've asked this question dozens of times, and every time, this is basically the answer I will end up with, which is, well, you put all the fields on your class. Yeah, the telephone number, the address, and the email address. And you set the ones to null that you're not using, and the ones that you are using, you fill in. And you can maybe do something like this, like if the telephone number is not null, then they must have the telephone number set, and we'll use that data. Or if the address line 1 isn't null, then that must mean we've got an address. Let's use that. Otherwise, it must be the email. Let's use that. Right? And then someone will say in the audience usually, oh, wait a minute, add an enum, because that will solve it. So we'll have an enum that specifies this is what I want. And then you can match over that and get the data. But it's basically the same thing. And if someone is accidentally sets the enum and forgets to set the data, then you'll get a null reference exception. And just in case anyone is thinking like, oh wait, C# has got now nullable reference types, that won't help you in this situation. You can't use it for mutual exclusion, so forget that. Let's skip that one out. This is the real way that you would do it in an object-oriented language, is you would use inheritance. So you would have a contact method abstract class, and then you'd inherit from it. So you'd have a telephone contact method, an address contact method, and an email method. And they'd have the data on it, and then you'd have a contact method on it as well. Who here would actually do that today? Like anyone? Yeah, like one person's raised their hands, 2 people. Who here would actually have done something more like enums and if-then sort of thing? Yeah, a few people more. Switch case sort of thing? I mean, I'm not sure what other way there is really of doing this, apart from those 2 kind of ways. The way you can do it in C#, I think 10 onwards, is you can use pattern matching. So that's kind of the more modern way, where you would have a subclass, but rather than using polymorphism, you'd have a single method called contact, and then you'd switch over the contact method. And you'd try and safely unwrap it. So you'd safely cast it across. If it's telephone, then unwrap it and use the data. But I don't see many people doing this today. And that's just an example of like how this sort of thing, it's not clear how to do this sort of, what should be fairly simple to do today, but in C# there's not a really good story for this yet. And that's the sort of thing that tag unions will solve. It will allow you to model mutual exclusion. A customer has this or this or this, and to safely deal with that data. Should you do what I've outlined today? We've still got 20 minutes, which is good. I can spend plenty of time. My gut feel is what I've showed you would probably be less than satisfying if you were to just stick to static methods, records, tuples, and a few other bits and pieces, because you're cutting away probably 60% of the language. You could start doing it, and your fellow colleagues on your team would come in and look at this and say, what have you done? Stop doing this. It's like completely unidiomatic C#. And it's just not what C# is designed for. More than that, the functional features are somewhat limited. I just want to show you again what Mads said, and he said this last week. So this is not controversial. C# is at its heart an OO language, and you're not going to get a full FP experience in C#. So you will get these nice language features like lambdas and pattern matching, but the fundamentals are never going to change. C# will always have this mutable state at its heart, and what we're really trying to do is go against the grain when we're trying to say, I want to do functional programming in C#. And there's a reason why that is. It's like the more times you add new language features, they have to integrate with every existing feature. And because C# has this mentality of we will not have any breaking changes ever, there's always a smaller space that new language features can fit into without going against any of the other ones. This isn't controversial, or shouldn't be. This doesn't mean that C# is bad or that F# is better. It is, but beside the point. What it just means is that you can't continually add features. It's not like, I like ice cream, I like cheese, I like chicken, and I like parsnips. But it doesn't mean that I can just throw them all into a big pot and I'm going to get something that's really tasty at the end of it. You can't just continually randomly add features, because you'll end up with something like that. So you have to really think carefully, especially as some features in a language will actively work against other ones. So just as an example, I talked about things like curried functions before. You can't really do them in C#, the same way as type inference is somewhat limited, because you've got these features on the left that are really good features in C#. We love overloading, for example, and we like cyclical references. And we wouldn't want to lose them, but if you have them, you can't do something else. Or if you do, it's somewhat limited. So don't think of features in a language as just additive, but they have to work together, and each one of them is a trade-off with another one. So when I hear people talk about FP on C#, I think there are some good things about that. People are more excited about this idea of functional programming. And from an F# perspective, which is what I'm very passionate about, I like that because features like pattern matching, lambda functions, unions, those were considered somehow difficult a few years ago, but nowadays, records are pretty simple in C#, and people realize there's nothing to be scared of. So that's like the good side. The thing that I don't like is, or that I'm worried about, is people will try and do functional programming in C# and then say, oh, it's really ugly, I have generic arguments everywhere. Or it's really ugly, I have to put read-only, and I have to put private everywhere, and I have to change all the way I'm writing code, and static everywhere. Or that we say, well, I know functional programming because I'm using lambda functions. There's nothing more to learn. Believe me, that's a very superficial way of thinking about it. And the better way to look at it is there are other things to do. The same as Mads has said. Try a language that is functional first, and you'll see just how the defaults are very different. And I'll show you that in a minute. So just to finish off the kind of C# story here and functional programming, I would say, yeah, there are no shortcuts. If you want to do functional programming, those kind of things I've talked about, expressions and immutability, you can't skip them. You have to do them. Otherwise, you're sort of building on unsafe foundations, and there's no point doing it. C# will always be an OO first language. That's not a criticism. That's just what it's optimized for, and it's great at doing that. And it's got some extensions that kind of make it easier to do some kind of functional composition. But if you want to do these kind of basic things, I want to work with immutable data everywhere, and I want to use expressions everywhere, C# will never, it's not optimized for that because it was never designed from the start. So don't see that as a criticism of the language. It's simply the design choices of it, and the fact that you can't do everything in one language. So this is where I come to the fun bit, and I've got 20 minutes left to really talk about F#. So that's the other .NET language. If we forget about VB for the minute, it's a great language as well. But from an interesting point of view, it's basically C# with a slightly different syntax. Apologies for that, but that's how I see it. You really should try F# if you want to get a feel for what functional programming on .NET really would look like, or does look like. In the same way that C# is optimized for object-oriented programming with some functional extensions, you can flip that around and think of F# as a functional first language with object-oriented extensions. So if you like, for example, link, you like records, you like pattern matching, you tend to be writing simple functions that you pass around, that is what F# was designed for. And everything about the language is geared up towards that way of thinking. So if that's sort of thing you like, you should really try F Sharp because you'll probably find it much more natural for what you want to do. The big difference is, whereas F Sharp, C Sharp rather, started with like these core foundations of like classes, mutability, inheritance in C Sharp 1, and then it's added it on top of that afterwards, these kind of other functional style features. F Sharp's always had this kind of two halves to the language. It's got a functional half and an object-oriented half, and the two don't really interact. If you want to do objects, go ahead and have fun, but if you want to do the functional side, then you have this very clean subset of the language that is just designed to do that really, really well. So, probably got slightly more than 60 seconds. I was going to do some coding in C Sharp, but when I was practicing for this slide, for this talk, for the last 2 weeks, I realized that I've just lost it. I can't do C Sharp anymore, and I was just fumbling everywhere. So that's why all the slides were pre-done. But I do know F Sharp somewhat, so I'll be doing that instead. So I'm just using VS Code here. That visible for the back row? All good? Lovely, thank you. So I'm just going to give you an idea of the language. Now, what I'm using here is in VS Code is this thing called a REPL, which is F Sharp. You can do console apps, class libraries, web apps, all of that. But it's also got this scripting mode where I can write code and just execute a few lines and get the results while I'm coding. So it's kind of like the immediate window when you're debugging C Sharp apps, but while you're typing rather than running an application. So you can just explore things really quickly. So I can say things like let x equals 5, and then I can hit Alt-Enter, and you'll see at the bottom here, I get x equals 5. And then I could do something like x plus 10, and I get 15 at the bottom. But I can do this with, I can create types, I can create data, I can do all sorts of things, and start working nicely. So I just want to show you now the two things that I started on, which was immutability and expressions. So for example, in F Sharp, if I say let x equals 5, you could sort of translate that to var x is 5, except in F Sharp, you can't mutate. So if I try and change this value, it says this value is not mutable, and I've got to put in the word mutable here instead. And then I've actually got a mutable variable. This is like the opposite of C Sharp, where by default it's mutable, and if you want to make something immutable, you've got to use read-only or const, and there are certain ways to get around it. In F Sharp, it's the opposite. Everything is const without you having to say it. In F Sharp, everything is an expression. So by that I mean even something like if-then. So if I was to say something like let y equals if, I don't know, system date time now hour equals 10, then hello Oslo else. Goodbye Oslo. So this is actually a branch of code that can actually have a result. So the result of this entire thing is assigned to y. So it's more like a switch expression. But in F Sharp, that's like if is also an expression. So you don't have this notion of like a statement. Everything has a result. And if you even have a void method, in F Sharp, that's not a void method. That actually returns an object that has no value in it. But you can still assign it to something. So everything has a result. In F Sharp, we call it unit. And this notion of unit is actually getting quite popular now, and I see it in some C# libraries where people are designing their own type called unit to do exactly this sort of thing. So records in F# are very, very simple. For those of you that are using records in C# today, anyone? Yeah. I was having a look at them, and I like what they give you. What I don't like is there's kind of two ways of doing it, and that you have to have these like init and read-only and other keywords that are sort of needed, and they kind of make it a bit more, a bit less pleasurable, should we say, to use. F# records are super simple. Like, that is it. You just say, I want a type person. It's got a name and an age. And there's really not much more to it than that. If you want to create one, then you simply start assigning the fields. And if you just look where my mouse is there, you'll see that the compiler already knows that this is a type person. I don't even have to give it a type. The compiler's smart enough to see, well, you've given it name and age. There's a type above called name and age. It must be one of those. And if I miss out one, it'll actually tell me, like, you've not given the field age, so please do it. So it's not dynamically typed. It's fully static. It's just really smart about inferring stuff. And of course, I get the usual sorts of equality. So these will be considered the same because they have the same value. Let's just define that. So person1 equals person2. In F#, equals means equals. It doesn't mean assignment. So you don't need the double equals anywhere. OK, good. And if you want to do sort of mutation-style stuff, you can say person with age equals 31. So the same sort of with syntax, except it's built into the language here rather than as kind of code-generated methods. OK. I want to show you briefly the calculator example that I showed you before, which was doing the adding with the logging, and just show you what that would look like in F# and how we can sort of make use of this kind of very simple function composition. And of course, yeah, I know this is a really arbitrary example of a calculator. I know that we're not spending our full-time jobs writing calculators. I get that. But if we remember, it had we were adding with a logger, and it had some state, and then it was the value we wanted to add. And we were doing like something like this. So we were saying logger, and that was a function that was adding value to state, and then we were returning it back out. Now in F#, you don't need to use the return keyword because everything is an expression, so we can just strip that out. We don't need curly braces because it's white space sensitive, so you just indent to get your scope, so you don't need to bother with curly brackets. And the compiler has basically figured out the types of all of these things for us. So if I mouse just above it, you'll see that it knows that state is an integer, value is an int, and we're returning an int. I could type them if I wanted to, like this, but that's not needed. The compiler is pretty smart and it figures things out. Oops, let's get rid of that. Now where it comes into a bit more power, and this is where things will be a bit foreign for looking at this from a C# perspective, is if I was to call this function, and I want to pass in my logger function. So here I'm just going to use console writeline. So I'm going to say system console writeline, and then I'm going to start with, let's actually invert these. So I'm saying there I want to use the writeline function as my logger. I want to add 10 to 0. And I can compile this, and then I can call it. And you can see at the bottom there I got adding 10 to 0. The answer is 10. Wonderful. What if I wanted to add another number to that? So I could either sort of bind that to something here. So I could say let x1 equals this, and then add that to x2. Or I could call it again. So I can say let's do this, and let's add 5 again. So that would be like the state for the second call. You know, this is the sort of thing we've seen in C# where you're chaining functions and you sort of have this expanding brackets. But it's kind of a bit ugly now. We're having to pass in system console writeline twice. If we'd have used object orientation, we would have passed that in as a dependency on the constructor. This isn't so nice. But F# lets us do the same kind of thing with functions. So I can say add with console. And then I've kind of built my own version of add, which just takes in the first argument, and the rest are still left standing, and I can still reuse them. So I've just kind of quickly composed the function, and I don't have to bother sort of doing that by hand. And then what I can then do is I can get rid of these parens, and I can invert them with this thing called a pipeline. So this says, take this value. Let me just get rid of this. get the value of the first line and pipe it to the second one. And then I can get rid of my parens, and I can get rid of this. And now I've got this nice little DSL that I've built very, very easily, where I can say start with 0, add 10 to it, add 5 to it, and add 7 to it. And it just flows line by line. And I've not had to create extension methods. I've not had to do much in the way of like hard work. This is just like fundamental features in the language. So it lets me build functions very, very easily and compose them in different ways. Well, how much time we've got left? We'll skip this out. Let's just look at some domain modeling very briefly. So this is the example I touched on before with the contact methods. And this is probably what it would look like in F# and what it might look like in C# with some syntactic differences. So I wanted to have different contact methods, which is either email or telephone or post. And if it's email, I'm going to capture the address, which is over here. If it's telephone, then I want to capture the phone number, which is an integer. And if it's post, I want to capture the 3 lines of the address. And then I'm going to compose that with customer. So I'm going to say customer has a name and a contact method, which is either email or telephone or post. And you can just continually plug these things together, and, or this, or that, and this, or that. We can create a record very easily, and then we can use pattern matching to match on top of this field. So I've got here a function called contact, which takes in a customer, and I'm switching on contact and saying, if it's an email, I'm going to send them an email. If it's a phone number, I'm going to call them. And of course, if I comment out a line there, then I'm going to get a warning that says, oh, you haven't handled the post condition. Please remember to handle that. If I was to put in an arbitrary email address there, then I'm going to get a warning, I haven't handled another email address. Please handle all the cases. And it will continually go through and make sure that I've handled every conceivable potential case of emails, telephones, and contact methods. Okay, jolly good. I think we're nearly done. Let's have a look. DVD. Yeah, the calculator I've already done. Okay, good. Yeah, fine. I haven't shown you everything in 60 seconds there, clearly, in F#, but take it from me when I say you can do all the normal things, like you have the full .NET framework, or the BCL. You can use everything from there. You can use ASP.NET Core. There are lovely web frameworks you can use on top of ASP.NET Core. You can also do F# in the browser. There's a project that lets you transpile F# into JavaScript. So we're using that to do full-stack web apps entirely in F# called SafeStack. You can have a look at that. But that's basically enough to hopefully get you interested in just exploring it and just seeing. You can open up VS Code, you download one extension called Ionide, and you're good to go. So just to wrap up, we've got 5 minutes left, which is fine. 1, is C# a functional programming language? I would say no. It's an object-oriented language with some functional extensions. How do I feel about the FP languages in C#? I think they're good to let you put your toe in the water to get a feel for it. But please don't think that if you find the experience suboptimal in C#, if you find it's a bit clunky when you're trying to do things like I've described, that means that FP is clunky. It's more the fact that it's not what C# was designed for. So should you try it? Yes, but don't expect a perfect experience. Like, take Mad's word for it, don't take mine for it. Try a language, ideally on .NET, because you know the framework already. It's not hard. File new project in Visual Studio or Rider. .NET CLI, .NET New. You have all the standard templates in F# as well. So yes, I would certainly try it. You can also do mixed language solutions, so you could do C# and F#. F# has a really good interop story. So you can write F# functions, and they just look like methods to C#. Records just look like classes to C#. Yeah, let's leave it as that. So I will just wrap up to say thank you very much. You can get me on Twitter, Isaac Abraham. You can contact me on our company email address, info@compositionalit. We are hiring. We don't need F# experienced devs. We don't even need .NET devs. We do provide visa sponsorship if you're interested. My book has just been released, finally. It took a bit longer than I thought. If you're interested, I do have some free codes to the book, so if you want to try it out, you can literally get started for free. Just hit me up after this talk, and I'll send you a code. So thank you very much. We do have 4 minutes. If you want any questions, just come over and we can chat. Thank you.
Okay, let's get started. Firstly, thank you all for coming. I can't believe this many developers have turned up for a talk about philosophy. I hope you read the abstract. So what we're going to talk about for the next hour is philosophy and architecture. And for the last couple of years, I've been working on a PhD in complexity science and software design. And in doing that work, I've come up with a brand new way of thinking about software architecture and a completely different way of doing the work that we do when we design software systems. And a lot of people ask the question, how do you do that? How do you come up with a completely different way of thinking about these things? And the way that you do that is that you go right back to the base of how do I view the world? How do I solve problems? What do I think is a problem? What do I think is a solution? And so for the next hour, we're going to look at what is the relationship between philosophy and architecture. And you might think that it's very, very far away from software development. But by the end of this 60 minutes, you'll understand the impact that your philosophical thinking has on the way that you design systems. So we'll start with a paper that was published in 2016 by Ralph and Tim Perrow, where they investigated the decision-making of software engineers. And they asked a very large number of software engineers, how do you make decisions? Whenever you have a software architecture and we see that you have 3 components solving a particular problem, why not 2? Why not 4? What lies behind that decision? And the almost unanimous answer of software engineers is, we don't really know. We're not sure how we make these decisions. We know it's right, but we're not sure how we arrived at that decision. There's a lot of vagueness about how we arrive at a particular design. And this causes us to ask the question, what is it that we do? What is it that architects actually do when we make decisions about the structure of a software application? There's 2 parts to that question. What is architecture in theory, and what is it in practice? And I always like to use this example when I'm talking about the difference between theory and practice. And so you'll see in this picture here, a 14-year-old boy called Taylor. And Taylor's father was a physics professor. And Taylor took some of his father's textbooks to his garage, and he built a small nuclear reactor, which kind of became a big deal for the local authorities. Now, whenever a 14-year-old can take some textbooks, go to a garage, and endanger a small town, then that's a pretty good sign that theory is pretty close to practice. That's a good sign. Now, I want you to imagine instead if Taylor's father, instead of being a university physics professor, had been an enterprise architect. And Taylor had taken some of those books to the garage, what would he have built? At the very best, a small fire. Or perhaps better for Taylor, he would have gone out and done normal teenage things. Why is this? Why is there this massive gap between our theory and our practice? Well, it looks like this. Whenever an architect represents an organization, which is a living, breathing, moving human system, the representation tends to look a little bit like this. At the highest level here, we have C, which stands for capability, which is how architects in the first movement start to break down an organization. It's a set of capabilities like sales or marketing or manufacturing. And we say that every capability is made up of a bunch of processes. And every process has a bunch of supporting software components. And when we look at this kind of diagram, what does it look like? It looks suspiciously like a circuit board. Now, why would we choose to map a human, complex, constantly moving organization as a circuit board? Why on earth would we choose to do that? It's because that's how we see the world. That's the way we've been trained to think. What really happens, what this thing represents, is a human system. And we have this blue character here inside our human system, which has people and groups of people and organizations and some software components. And what happens is This blue character wants to do something in the world, and they stumble around trying different things until eventually one day they reach the market up here that they wanted to reach. And once they've done that, they have a business, a successful business. And what they do is, then the enterprise architects come in and they take these white arrows and they map it to this kind of rigid circuit board-like structure. And they say, here's your architecture, we're done. What they don't see are these green arrows, and these are things that the British researcher Ralph Stacey calls hidden transcripts. They're the hidden relationships, the hidden thoughts, and the hidden groups that exist in a social system that you can't actually capture or see or write down because they're constantly moving and constantly changing. These things cause so much problems for us, we had to move to agile ways of development to cope with them. And what happens is that these green arrows, they pull on the network, they pull on the system, they influence it, they change it. And then all of a sudden on the periphery, new technology and new actors pop up. And there's a new way to solve this particular problem. And when that happens, we call it disruption. And when that happens, the white arrow architecture that we've put years of work into collapses completely and actually becomes a problem for the organization. The obvious example of this happening in the real world is Blockbuster, which in the United States had a very successful business with their white arrows where they hired movies to people on the weekends. And they made all their money on late fees. And they didn't see the green arrows, which was the seething hatred that was building up in their customer base because they constantly, every Monday, had to pay a whole bunch of late fees because they never left their movies back on time. Netflix saw this and popped up. And all of a sudden, there was a new way to reach this market. Blockbuster had the opportunity to buy Netflix, but they passed over it. By the time they realized what Netflix were going to do with streaming, they went back to their architects and they said, can we fix this? And their architects said, yes, but it'll take 18 months because we have this big, heavy white arrow architecture. 18 months later, they were bankrupt. That's what can happen when you view human organizations as these stiff circuit board-like things. So what is architecture in theory, then? In theory, we think that we work in a very structured way. We believe that we're scientific because we studied computer science. We believe that we're mathematical because computer science has its roots in mathematics. And that we're analytic. And that we're rational. And we believe this of ourselves, that we're scientists, we're engineers. I don't think this is strictly true. Architecture in practice is sheer, unadulterated panic. We don't know what's happening. When we think we know what's happening, everything moves and changes. And it's very, very difficult. But we still pretend that we're using some kind of theory. When a junior architect comes to you and says, how do I do architecture? You say, read this book and read this book and read this book and this blog and do this thing. And if they ask you, do you actually do the things that are in this book? We know that we don't. Right? But we pretend that we do. And the consequence of that is that we struggle to articulate the basis for our decisions. So basically, architecture is mostly lying. There's a very interesting article that was written in 1986. It's called A Rational Design Process, How and Why to Fake It. And this article, when I first discovered it a few years ago, made me giggle. Because it starts off by saying, look, there's no structured, rational way to do software architecture or software design. It's always a mess. It's always chaos. But the article goes on to say, it's worthwhile lying to management and pretending that you're doing things in a rational, structured way. Otherwise, they get very nervous. And so this isn't just my thinking. This article also says the same thing. And I thought that this person was being sarcastic, and then I looked at the name. The author of this article was David Parnas, one of the most important researchers within software engineering in the last 50 or 60 years. That's where we're at. And so the question is, why are we like this? And that's the question we're trying to answer here today. Philosophy gives us a tool to help us question our assumptions about the world. It helps us ask deeper questions than the everyday design of components and systems. We want to ask, how did we get here? Why do we think like this? What do we actually believe about the world? And in order to do this, we'll have to look at a couple of the problems that we see with software architecture today. The first major problem, the biggest problem in software architecture, is the problem of time, change, and uncertainty. Architectures, we draw them as static two-dimensional diagrams. We say, here's my architecture, a bunch of components connected to other stuff. What we don't represent is the fact that that architecture will not look the same in 6 months or a year or 2 years. It will constantly change over time. We don't capture that. And the reason that we don't capture that is because we don't actually know. Nobody actually knows how things are going to change over time, not even our stakeholders. And this makes it very, very difficult to do architecture. Another issue that we have, which is a philosophical issue, is that we don't really have a unit of architecture or a unit of software engineering that we can gather around. What does that mean? Well, when you have a unit, when you have something that we all agree on is true, then you can build a science around it. And the Greeks realized this 2,500 years ago. And they started to say, what is at the core of all this? What is the unit of the universe? And they came up with some crazy ideas, like it's earth or fire or wind or water. And those were reasonable starting points, actually, when you look at it. Eventually, physics arrives at the atom, and that came from a Greek called Democritus. And the atom becomes the unit of physics, and we can build a whole science around the fact that everyone's in agreement that there is this thing called an atom. Although some people on Twitter were disagreeing a few weeks ago, but we'll not dig into that now. For us, for a lot of us who've studied mathematics, the Newtonian particle becomes the unit with which we assemble around and build a science on top of it. Chemists have the molecule, biologists have the cell, and this allows them to be successful, to communicate with each other and build a base. In software, we've been having a bit of a journey. We're not quite sure where we're at yet. We started with the machine. We were very tightly coupled to that. Dijkstra saved us. We moved to punch cards, procedures, modules, objects, which has entertained us for decades, services, and then eventually we move into things, business concepts like processes or features or functions, patterns. And the chances are, if you've got a group of software architects assembled around a problem, they're all working from a perspective with a different unit. And this causes lots of friction and lots of weirdness and lots of disagreement. And we're still in the Greek phase of earth, fire, wind, and water. We're not entirely sure what we're about yet. In 1962, a philosopher of science called Thomas Kuhn wrote a book on the structure of scientific revolutions. And he talked about how scientific ideas change over time. And he said that a scientific idea will exist for a certain amount of time and people will assemble around it and they'll build knowledge on top of it. And what will happen is that the scientific idea will start to suffer from some anomalies. There will be things that it can't explain. And as that starts to happen, people start to doubt the idea. And some people desperately try to patch the idea and keep it alive, and they become very defensive of it. But after a while, the idea collapses and is replaced by something new. And that's called a paradigm shift. And in science, we have these huge paradigm shifts every couple of 100 years. In software, we have these huge paradigm shifts every 6 weeks, it feels like. It's constant, and it's exhausting, and it's a sign of where we are. All of these problems are philosophical problems. They require a different way of thinking. You cannot code your way out of these problems, and we have tried to do this. And so, I'm going to have to give you a little introduction to some basic ideas in philosophy. I usually describe myself as a software engineer who got lost in the philosophy department of the library. So if you're watching this on YouTube and you're a proper philosopher, please don't do that comment thing, okay? So 2 very important concepts to us, and an important concept to the history of Western philosophy, is the difference between essence, and essence is the core of something, the way that we think about something, the way that we group things, and appearance, which is how it actually appears to us, how it behaves in reality. And a lot of Western philosophy is about noticing the differences between these two things and trying to make the differences go away. And a concrete example for us is that the core, the essence of something, is the requirement specification. We've tried to boil it down, we've tried to capture it, we've tried to describe it in detail. And then, of course, you have reality, which has absolutely nothing to do with the requirement specification. And the difference between these two things isn't just something that happens in software, it's a problem that's been around since ancient Greece, and we don't really know how to solve it. In ancient Greece, there were two huge thinkers that shaped the way we think in the West today. The first one is called Heraclitus. He's the guy with the white hair and the beard who looks like a senior software engineer. Heraclitus said that the world is made of fire. Everything's burning. Everything's moving. There is no things. It's just an illusion. Everything's moving past so quickly, and we're trying to make sense of it that we think there are things. Heraclitus is famous for the phrase, "No person ever steps in a river twice because they're not the same person and it's not the same river." You've probably heard that phrase before. And that description of the world is probably feels very familiar and comforting to you as software engineers. This is the way our world works. Everything's moving past so quickly, we keep getting it wrong. On the other side of the coin, we have someone called Parmenides. And Parmenides is the guy here who looks more like a product manager. And Parmenides said that everything is still, nothing is moving. Everything in the world is still. And the reason you think it's changing is because our brains are a little bit funny and we can't cope with the stillness. So we make up this change. And these two thinkers were in direct opposition to each other. And they were both a big influence on Plato. And Plato is the founding father of how we think in the West. And Plato chose to side with Parmenides. He chose to side with the fact that the world is still and that we gain knowledge by gaining knowledge of the things that are actually still, the essences at the core, when our brains stop being confused about what's actually happening. And that decision by Plato might seem a very, very long way away from software engineering, but it affects every decision that you make in your architecture today, which is pretty cool and pretty scary. So at this point, you might want to ask yourself, what is my philosophy? What is my philosophy of software engineering? And most of the time, we won't be able to answer that question because we've never been taught how to answer that question. We spent all our time doing cool stuff with algorithms at university. And what actually happens is, it turns out that we all have a default philosophy which we've never been taught how to question and we've never asked about it. And that default philosophy comes from our university professors. And we have to ask the question, where did we come from as architects? And this is where we come from. You should recognize most of these names on the screen, hopefully. These people all had one thing in common. They were, more or less, they can be described as positivists. They all have a similar philosophical view of the world. What does that mean? Positivism is a school of philosophical thought that believes that the universe is clockwork, that the universe is just a big bunch of gears, and if you figure out what way they're linked together, then you'll know which ones to turn in order to make things happen. They believe that there are independent, objective laws that govern not only the physical things around us, but also our society and our minds, and everything can be mapped, like circuit boards, like chips. This way of thinking is very much based on logic, and without this way of thinking, we would never have had computers. This is what gave us logic, this is what gave us Turing and von Neumann, this is what gave us the computer. But it also gives us the software crisis because of the difference between essence and appearance. There is another way of thinking, which we can loosely group and call interpretivism. And so where positivism looks for laws that govern the universe and uses scientific method to investigate social systems and believes in observation, experiment, and logic, interpretivism allows there to be different views of the same reality. And it rejects the scientific method for social systems on the simple premise that it has never worked. And interpretivists will say that knowledge isn't something out there that we discover using the scientific method, but knowledge is something we come to through ideas and debate. And the fact that you're all here listening to me talk about ideas is proof that this is how we learn. Otherwise, you would all be back in your offices doing experiments, which we don't do. And so there is another way of looking at the world. The problem is that we come from the positivist side and we think that that's what rigor is and we think that that's how you should solve problems, but we actually act like interpretivists. And there's a problem there, there's a dissonance there. Now, every single one of us, because of our university educations, has a default philosophy. If you haven't thought deeply about these questions, you're probably going to recognize how you think across the next couple of slides. The first thing that will appear in your default philosophy, if you start scraping at how do I see the world, is a way of thinking called essentialism. And this comes directly from Plato. Essentialism says that there is a core essence to everything. And Plato believed that there was a heaven somewhere, a heavenly realm. And in that heavenly realm, there were these ideal forms. So somewhere in that heavenly realm, there is a perfect cat. And every cat on earth is just a crappy copy of that perfect cat. This is what Plato believed. And he believed that wisdom was gained by getting closer and closer to understanding what the perfect cat is. And when I tell you that, most of you are probably thinking, what a silly idea. But, you know, this was 2,000 years ago, so it's okay to have silly ideas. I give you object orientation. Object orientation is exactly the same way of thinking. I have this perfect class, which I've described, and all these crappy little objects, instances executing in reality. We've taken these rather strange ideas from ancient Greece, and we've turned them into the base way that we address the world. If you do enterprise architecture with something like TOGAF, you'll find things like architectural building blocks, solution building blocks that play the same role. Patterns can also play the same role. Now, that's fine when we're talking about cats, but when you apply this kind of thinking to larger systems that have lots and lots of different things in them, you end up applying a new way of thinking, which we call structuralism. And structuralism is about the ideal structure of something. And so when you start drawing lines and boxes and relationships between things, you're engaging in something called structuralism. About 100 years ago, some people thought that there's a structure in our language that reflects the underlying structure of reality, and they started looking for that. And those ideas were pretty quickly discounted, but they still turn up in software engineering in the form of requirements engineering, where we try to find reality behind the language that our stakeholders use. And some approaches, like domain-driven design, will go even deeper and try to find that structure in language that represents a real structure, which is the essential form of our organization. A third thing that you'll find in most software engineers is a naive idea of something called cybernetics. And cybernetics is a set of ideas that was developed in the 1940s by a mathematician called Norbert Wiener. And he believed that that a machine consists of feedback loops, and you get control through controlling these feedback loops. And he started to see feedback loops in animals and people and in our society and everywhere. And this led to a way of thinking where we've seen our society as a machine, as a set of interlocking feedback loops. And this led to us thinking about things as machines. Other philosophical ideas that you all carry that are important is causality. We see social systems as machines, and we believe that there's an if A, then B relationship between things in a social system. Turns out it's not that easy. We also believe that there's causality in structure, that if you reorganize your company, you'll cause a different future and you'll be able to control that. And that turns out to be exceptionally difficult as well. And the worst kind of causality is rational causality, where if you get a bunch of managers in a room and they decide on a strategy, then that's what the future is going to look like. We cause the future by having strategy meetings. Turns out that doesn't really work either. In real-life architecture, when it comes to causality, stuff just keeps happening, and we have no idea why. This all collects into one set of behaviors that we use as software architects, and that is models. architecture is all about taking these ideas, structuralism, essentialism, machine thinking, simplistic causality, and turning it into a model. And what we actually do is we take reality and we cover it up with models until there's nothing left of reality and we don't have to deal with it anymore. And for some people, that's incredibly comforting. Now we can just sit in the basement and show each other pictures. We don't have to think about the reality behind it. There is a philosopher who was active in the latter part of the last century, a French philosopher called Baudrillard. And I've been told by some French people that that's definitely not how you pronounce it. And Baudrillard wrote a book called Simulation and Simulacra, which talks about this exact problem, that we create these models of reality and we start to live through the model instead of the reality that's there. And this book, this picture might be familiar to you because in the movie The Matrix, which I'm assuming most of you have seen, though I can see that some of you weren't born when it was released, whenever Neo goes to find his contraband, he has a hollowed out book and he has his phone and some other stuff in there, and that book is Simulacra and Simulation. The movie The Matrix is based on this book. And Baudrillard talks about how we're losing touch with reality. We're living our lives through television, which is a mirror of reality, but it's not quite the same thing, and we're getting a little bit confused. And a lot of times, you'll hear architects being accused of living in some kind of ivory tower disconnected from reality. And it turns out it's not an ivory tower. We're actually in the matrix, and it's the matrix of our own making. And as soon as I tell architects and developers we're in the matrix, they all say, well, I must be Neo or I must be Trinity. You're not. You're actually the architect. And the architect in this movie looks exactly like Norbert Wiener, the guy who said that society and people were just feedback loops of machines. And that is not an accident. The people who made this movie knew their philosophy. They knew what they were doing. You can tell that this guy is a real architect because he promises utopia in version 1. And it doesn't quite work out like that. And when it fails, instead of changing his mind, he just tries to patch it. He says, it's broken, add the oracle. It's still broken, add Agent Smith. It's still broken, add the 1. And it just keeps going. The reason that the system fails is because he fails to take into account that human beings have emotions. That's something that we regularly do in our industry. Neo falls in love and the entire system collapses. That's what happens when you have these green arrows that you can't see. And of course, he creates this massive model that obscures reality so that no one actually knows what's real anymore. And so what we have to do is get out of this matrix. And how do we escape the matrix? A lot of times when we talk about architecture, we say that what we're experiencing now is complexity. And this word is massively overused, and my studies have been within complexity science because this is what we think we're experiencing. And some people think that the way to get out of complexity is to suppress it. Let's get rid of it. We just encapsulate, whatever that means. Or we say, that's never going to happen, Yagni, we don't need to think about these things. Some people think that if you just keep iterating, you'll get out of this complexity. And that can be very tiring. And some people believe that you have to go back to the scientific method, to positivism, and design experiments and run those experiments. The way out of complexity in the past has always been the same. You need new concepts, new ideas, and a new philosophy. And to have a new philosophy, you have to break out of the old way of thinking. And that's the challenge that we stand in front of today as software engineers. If you think about the huge scientific changes that allowed us to cope with complexity, they didn't come from experiments, they didn't come from iteration. The reason that we have most of the engineered things we have today is because Isaac Newton allegedly got hit in the head by an apple, and he made a jump, a new concept. Darwin was staring at a bunch of finches when he realized that, there might be a different way that things work. And Einstein's idea of time also came as a new set of concepts, a new kind of ideas. Every time we develop a new set of concepts, we conquer complexity. We don't conquer it by tinkering at the edges of it. And I'm going to give you a set of new philosophical concepts that you don't have to adopt, you don't have to believe in them, but it's a different way of thinking about the world than the default philosophy most of us have as architects. And those three ideas are process, criticality, and difference. So whenever we focus on the thing, whenever we try to identify what is the perfect ideal cat, what does it look like? What we're doing is engaging in something called substance philosophy. And substance philosophy comes from Plato and Aristotle, and it's all about focusing on the thing. What is the thing? What makes it a thing? What makes another thing not this thing? What are the boundaries between them? And there's another way of thinking, and it's called process philosophy. And process philosophy is very much Heraclitus' way of seeing the world. Everything is moving, everything is changing. And even we are changing as the things are changing, and the way we think about them is changing at the same time. It's a completely different way of looking at the world. And one of the questions we ask is, how do we gain knowledge? And so from the Platonic way of looking at things, from substance philosophy, we gain knowledge by looking at things, putting them into categories and putting them into little boxes and saying, this is a cat, and this is a dog, and this is a sheep, and this is an object, and this is a service, this is a load balancer, this is a test. This is how we gain knowledge, and we learn these things as facts. There's a different way of learning that we use as architects. And it works like this. I've just moved house. I've moved to a new town. And I want to go for a walk. But it's a new town, so I don't know where I'm going. So I go to Apple Maps and I pull up a map. And I plot a little route. Those are car times. I'm not lazy. It's a longer walk than that. And I say, this is the walk. And this representation of the walk is Platonic. This is an ideal form of a walk. This will describe a walk in any part of the world. But as a source of knowledge about that walk, it's pretty useless. And so the first time I take this walk, I have my phone in my hand. I'm very nervous about getting lost. I walk around and I make sure that I'm taking the right turn at the right time. And all my focus is on not getting lost. And this representation has done its job. The second time I take this walk, the walk will not be the same. There will be slight differences because things are changing in the environment and because my perspective of this walk has changed. And I notice on this particular path, there's a lot of shade. And I live in Sweden. That means there's a lot of mosquitoes. So I don't want to go there. Now I have knowledge based on that small difference between the repetition. I take another walk on a different day, and I realize that in the winter, on this particular path, no one puts any sand or gravel out, so it's very slippy and it's very dangerous. So I don't want to walk there in the winter, and that's another piece of knowledge that comes from observing the small differences every time I repeat this walk. And then I realize that if I leave at a certain time in the summer, I get to experience this view, this sunset. And I take lots of walks, and I learn that some days it's maybe better not to just take the walk at all. And I learn a lot of things. Every time I repeat the walk, I notice small differences from my previous experiences, and those small differences add up to solid knowledge about this walk. Now, we have a problem in software architecture. Sometimes we believe in things, and everyone believes in different things. And you can meet two architects with two completely different sets of beliefs about what tools they're meant to use. And the strange thing is that both of those architects, if they're good architects, will succeed, even though they have a completely different stack of tools and ideas to build their architecture. And that's confusing, because it means we can't answer the question, what is the best stack? What's a good stack of tools? What's actually happening to these architects is that the tools they use don't actually help. They don't deliver anything. All those tools are doing is that they are triggering walks around the problem over and over and over again. So you think you're doing requirements, and then you think you're doing risk, and then you think you're doing patterns, and then you think you're doing test-driven design, and then you think you're doing something else. All you're doing is walking around and around and around the problem until you build enough knowledge to know what's actually going on. And this is universal to every architectural process. You could say it's an essence of architecture. And the third thing, these ideas were written about by a French philosopher in 1968 called Gilles Deleuze, which apparently, according to my French friend, is not the right way to say that either. The third thing, and this is critically important for architecture, the third concept is the concept of criticality. Criticality is a property that a complex system has when that allows it to survive things that it hasn't been designed for. So your immune system has criticality because it can defend you against diseases that aren't in its design, that aren't in its specification. It has flexibility through the number of components and the relationships between those components. We are critical beings. Our societies have criticality. Forests have criticality. They can repair themselves. They can cope with unforeseen circumstances. For programmers, their goal, and when you've gone to university and learned computer science and programming, your goal will always have been correctness. This algorithm has to be correct, this function has to be correct, this has to work in a specific way repeatedly. The goal of a programmer is correctness. That should stay. But the goal of the architect is never correctness, because you can't be correct in an environment that's constantly moving. The only thing you can be is critical. And that's a completely different idea. It changes entirely how we think about software. And so what we're doing is I'm giving you a bunch of new concepts that will help you to navigate the complexity that architects experience every day. Process instead of substance, criticality instead of correctness, difference instead of essence. And this is an enormous philosophical shift. I'll give you an example of the way that this works. What we're actually doing is we're allowing our concepts to be destroyed. So I'm building a system, and I start out with a concept called customer. Customer has a bunch of properties. It has a name. They have a name. They have a social security number. They have an address. They have a credit card. This is my customer concept. This is the ideal customer for our business. Then we take a couple of walks and we realize that there's differences. Suddenly I have a business customer, and a business customer doesn't have a social security number, they have something else. And a business customer doesn't have an address, they have lots of addresses and lots of opinions about which address we should use for particular orders. And business customers don't have credit cards because they have invoice functions. And your customer object suddenly blows up. It's no good anymore. And so you might think, well, we'll update it, and we'll say, if it's a person, then they have a social security number. If it's a company, then they have a company number. Then we get a different customer, a foreign customer who doesn't follow any of these laws, and we have to change everything again. And then we get this demand to be a one-time anonymous customer where you don't get to know anything about them, but you still have to serve them in some way, and the concept collapses again. If you ignore these conceptual collapses in your architecture, you're going to constantly be chasing your own tail, and your architecture will suffer, and you'll end up patching things in the way that Thomas Kuhn describes. So when our essences and appearances don't match, what we do is we speculate, which is a fancy word for we make stuff up. Speculation leads to a lot of noise and a lot of nonsense. And if you're a positivist, there's no tolerance for noise and nonsense. But it turns out that noise and nonsense and truth are very hard for us as software architects to tell the difference between. And so this is an important part of how we learn. And using process difference and criticality allows us to make that speculation useful. Now, the ideas that I've come up with, and some of you might have seen the talk from NDC last year, is based around the idea of a residue as a unit of software architecture, as a way of capturing time, change, and uncertainty in our architectures. And it describes the architecture across many different timelines that we discover through this architectural walking. We just make these things more explicit. And it embraces speculation through the use of random simulation. So rather than asking people for requirements, we just throw lots and lots of potential requirements at the system, whether they're true or not. And this gives us, with a statistically significant result, a better way of building architecture. This requires a shift in how you think if you're a programmer. Programmers use something called linear thinking. Linear thinking is about direct problem solving. It's mathematical, it's concrete. Your focus is in getting correct answers. And it's the key skill for a software engineer. If you can't think in a linear way, you're not going to write good code. As you move to architecture, you need to think in a different way, and this is called lateral thinking, and it's vague and it's fluffy, and it's asking what if and using your imagination, and this is one of the things we have to unlock to be able to do this. Architects need to be able to do both of these things. And then you have to ask yourself the question, do I want to be an engineer and live in the linear world where everything's easy and code and logic and I don't have to talk to people? Or do I want to live in the fluffy lateral world? And if you read these two books and see how it feels, you'll get a good sense of which one of these am I. The book, How to Solve It, is linear thinking. It tells you how to solve problems. It should be very familiar to most of you, the techniques that are used in there. The second book is on lateral thinking by De Bono, and it talks about how you can actually train yourself to think outside of these rigid logical structures that you've been taught in your computer science degrees at university. Linear thinking, it turns out that the very best developers are usually excellent linear thinkers, and sometimes when you push them into architecture without preparation, it can be very, very painful because it's a completely different way of looking at the world. But if you go back to the basics and have a look at your philosophical beliefs about the world, then these things become much, much easier. And so the conclusions from this work is that as a software architect, as someone who designs software systems, you already have a philosophy. And you probably didn't decide yourself what that philosophy is. You've absorbed it from your computer science professors, you've absorbed it from the industry around you, you've absorbed it from your company, from your colleagues. It's encapsulated in gut feeling and something called reflective practice, where we learn over time through walking. It's surrounded by marketing, by random ideas, by moonshots. There's a lot of noise and nonsense in there, and we can't tell the difference between what's real and what's not. Learning to understand this and learning how to express this is incredibly important in your development as a software engineer, as an architect. But it's also important to link this back. You have to get things to work. That's still what we get paid for. And so how do we unplug ourselves from this matrix? The way that we do it is to be responsible for your own philosophy of architecture. Don't accept the default that you've been given by the industry and by your education. Question how you fundamentally see things. There's a bunch of reading you can do. I've dropped the names of some philosophers you can look up. Expose yourself to thinking outside of STEM. The humanities graduates are really, really good at this because they've been taught how to think outside of the boundaries that were set for us in our university educations. There's a potential goldmine of new ideas and theories in the heads of every single one of you in this room. If you use these ideas, you can unlock those things. I was able to do it, and I came up with one set of ideas, but every good architect in the industry is capable of doing this with the right philosophical leaning. Read outside of your discipline. And the goal of this is that we should control the model. The model should not control us, which is the lesson, of course, of the Matrix movie. And this is what you'll be able to do if you embrace these ideas. And the final lesson is that it's not the spoon that bends, it's only you. You won't be able to change reality. You won't be able to make these stakeholders smarter. You won't be able to make them give better answers. You won't be able to make them realize that this is a bad idea or this is a good idea. The only thing that can bend is you yourself, and these tools, these ideas, will help you to do that. And I guess where you go from here is up to you. This would have been a good point to have that Matrix music kick in, but copyright is tough, right? And you can find out more about these ideas in this book, or if you have any questions, you can reach me at these places. And so thank you all for coming. It's absolutely incredible that so many developers came to listen to a talk about philosophy. I hope you don't regret it too much. And good luck out there. Thank you.
All right, let's get started. Welcome to my talk from human computers to AI. The year's 2035. Jill wakes up 5 in the morning. She makes the 2-hour commute into the city. Most people in tech can't afford to live in the city centers anymore. They live in the suburbs and the outskirts. Still, Jill's one of the lucky ones. At least she has a job. As she exits the train station, she passes by the tech bros. That's what they call them nowadays, the jobless guys hanging out on the street corridors trying to peddle off-label software and NFTs to people passing by. As Jill enters the building of Titan Tech, where she works, she scans her badge and her retina. The technology Jill is working on is so proprietary, it's not allowed to leave the building. The days of remote work have come and passed. The building is empty. It's a huge building, completely void of life. There's maybe 20 people working there, and they rarely meet each other. Sometimes they see each other at lunch, most times not. Even though Jill has almost a full floor to herself, she works in a very small space. It's almost like a cubicle, except it's just 8 screens that she's surrounded by. The work Jill does is mostly fine-tuning Titan Tech's developer AI. It's the AI that writes all the software in the world. Now, Titan Tech does not sell this technology or give it away. What Titan Tech does is it produces every piece of software that exists in the world. Because nobody can compete against the AI. So Jill understands the irony. She knows that she made herself and all of her colleagues redundant. And with every fine-tuning, every line of code she puts into the system, she makes herself even more obsolete. Today, Jill eats lunch at her desk. She can't stand the look of the other people's faces in the cafeteria. They're all very sad and have mostly given up on life. On Jill's desk, there's a little digital clock, black one with red numbers. It's not connected to anything. It's a remnant of how things used to be. In the afternoon, Jill sifts through new training data and commissions training data to the code factories. When 6 o'clock rolls around, she packs up her stuff and exits the building. As she walks towards the train, a police drone passes by. That's also Titan Tech technology. Everything is nowadays. In the underground, she passes by one of the code factories. Deep inside there, she sees what she thinks is Jake. Jake is an old colleague of her. They used to both be tech leads at Titan Tech. She hopes Jake doesn't see her, because at the code factories, these are the places where Jill commissions training data from. Most people that know anything about coding, this is their only employment opportunity. They sit there and they solve puzzles for 40 cents a puzzle. A guard grabs a man sitting in a computer and drags him out into the streets. That's what happens if you take too long to solve the puzzles. Jill looks down on the ground and quickly goes towards her train to commute back home. My name is Martin Masur, and I'm a consultant, coach, and speaker with over 20 years of experience in the industry. I used to work as a software developer, but I've been made redundant by young people. So today I work on improving collaboration between business and tech teams so that everybody else can just focus on delivering cool products. In today's talk, you will learn the abbreviated history of our profession of software development, along with all the assassination attempts that have previously been on our profession. You will learn how to prepare for the technical shifts and what skills might be required of you. And if you stick around to the end, you will also learn how you can change the future. Now, the history of our profession started a long, long time ago. It goes as long back as to the 1800s, before we had computers. at least before we had computers. So before we had computers, we had what was called human computers. Now, these were people, well, mostly women, sitting and doing a lot of the calculations by hand. And the first documented practice of this is in 1875 at the Harvard Observatory, where women used to take plates of the night sky and calculate the movement of the stars. So the man who founded that practice is called Charles Edward Pickering. And he had this brilliant idea that since this seemed to be very boring and very tedious work, he could just employ women to do it, and that way he could pay them less. So that's how that practice came about. And that continued for many, many years, the manual computation of things, all the way into the 1940s and 1960s. In the 1940s, women were calculating everything from rocket trajectories to artillery trajectories for NASA and the military. They could solve really, really complex problems, and the way they did this was by taking these calculations and splitting them up amongst each other and then aggregating back the results into the final output. The reason this continued all the way to the 60s, even if we got, mechanical computers, was that while mechanical computers were quicker, the people doing the work were actually more reliable and efficient. And also, everybody didn't really trust the machines. So there's like a theme going on with that. We're not trusting in the machines. And history is messy like that. Nothing, things don't just start and stop. So even though this practice continued all the way into the 60s, we saw a new era of digital computing in the mid-40s. So the first digital computer, the discovery of the first digital computer was fueled by war. So like many historical inventions. The year was 1945 and the ENIAC was unveiled. This was the first generation of the electronical general purpose computer. And the reason it was unveiled was because there was a need for doing quicker and more accurate computations. So the ENIAC was capable of doing thousands of calculations per second, surpassing human abilities. Now, since most men were out at war, and the people who actually knew how all of these computations worked were women, the people programming the ENIAC were still women. And the way this was done, the way the programming of an ENIAC was done, was by using these manual plug boards and switches. So to input a new program, you had to physically reconfigure the whole computer. Then inputs and outputs were mostly done on punch cards. Later we got the EDVAC, which was the first computer that introduced a stored program architecture, which meant that the input and the program could be read in the same way. Now, this changed everything because this meant that you could switch programs much quicker. Now, still, the programs were done mostly on punch cards, and mostly on punch cards. But with this introduction, what happened was that programming went from like a configuration task to an actual creation of the program. So even though now we were programming, we were actually doing programming, much of it was still this binary language or assembly language type of programming. This meant one thing: it was really, really hard to do. And secondly, it was machine specific. So if I made a program for this type of machine, I couldn't bring it to another type of machine because all the programs were specifically tied to how the hardware was built. Now, these two things were a huge industry problem because neither programs nor skills were transferable from one computer to another. So enter the era of programming languages. Now, the first major breakthrough in programming languages was Fortran. So while Fortran was considered a more modern language written with instructions and compiled, it was still largely done with punch cards. The second breakthrough came with Grace Hopper, a woman that was part of the UNIVAC team, which was one of the first computers for business purposes. Now, Grace believed that computers should be given instructions in plain English. So she pioneered many of the ideas which later became modern programming. Eventually, her ideas led to COBOL in 1959. And with COBOL came, well, you guessed it, with COBOL came the first assassination attempt on our profession. So because there was this huge rise in demand for business software in the 1960s, it was the first time the idea came about of replacing all of these pesky computer people with, something else. And with COBOL, a language that was designed to express programs in business language, and it almost read like English, came the idea that maybe we can democratize software development and cut out the middle person. The reality, well, writing COBOL programs was really hard, and it still required deep technical knowledge of both the machines and the programming languages. So who would have thought that that would actually be the case? So instead of eliminating programmers, what happened was that there was this massive surge in demand for COBOL skills. Now everybody wanted skilled COBOL programmers. So this is how we made it through the first assassination attempt on our profession and actually emerged stronger at the back end. Now, the next thing that happened was actually that we got our first label, right? Because up until this period in time, programming had been something that, it'd been a skill, like people did it in their jobs, but as an add-on to other things they also did. So this is Margaret Hamilton, and what Margaret Hamilton worked on the Apollo 11 project, and she wrote code for the moon lander. Hamilton had an engineering approach to programming and development, and she wanted to professionalize the skill set and have it taken more seriously. Now, she recognized that software was usually seen as an afterthought, like something you kind of put onto the hardware. But she wanted to make it a legitimate process and profession. And she did this by coining the term software engineering, as a contrast to hardware engineering, which was more prevalent back then. In the beginning, this wasn't really taken seriously. A lot of people made a lot of fun of it, as she's attested to in interviews. But eventually it caught on, and now we had a label. Now we knew what we were. We were software engineers. So this did lead to a professionalization of the craft, which is really important, because when you professionalize something, you also create a discipline around it. When you create a discipline around it, you create ways of working, you create a shared knowledge, you create things you can study and talk about. So now we knew what we were. And this rapid and chaotic growth of software during the 60s and 70s led to something else. It led to something that was coined the first software crisis by Dijkstra. And the issue was that the things that we were doing were really, really hard to do. And it was specifically hard to do them correctly, especially when trying to build these large-scale, reliable software systems. So quality was poor, budgets were overrun, and deadlines were missed. I'm not talking about today. This was in the 60s and 70s. But I guess not much has changed. So Dijkstra coined this term, the software crisis, and he said, as long as there were no machines, programming was no problem at all, and now we have gigantic computers, programming has become an equally gigantic problem. And because of the crisis, we saw the beginning of what we today call software development. So in his speech, the humble programmer Dijkstra addressed three things to solve the ongoing industry crisis. One, he had a call for structured programming, which meant you need to keep your code clean and well organized. Secondly, proof of correctness. This meant that you needed to mathematically prove that your programs to be correct. A big part of this was having a specification, knowing what correct actually meant. And the third one was abstractions, meaning breaking down the large and complex problems into smaller bits and pieces that could be more easily managed. So this was the beginning of the formalization of the craft. These ideas have inspired everything from design patterns to architectures to ways of working. And it all happened because we created a big mess, a big ball of mud. So, of course, things didn't get better overnight, but over time we managed to figure things out. And the next significant impact on software engineers actually came with the introduction of a new technological marvel, the microprocessor. Now, this was a very compact, affordable circuit that contained the functions of a CPU. Up on this time, it was unthinkable to have a computer in your house. You had to go somewhere to use a computer, which was usually your job or a university. Now, this drove the price down, and it was now possible to have these computers in your house. The first microcomputers were sold as kits, meaning you ordered them online, or not online, sorry, online. You ordered them, and you got them home, and you had to build them yourself. So these were mostly used by hobbyists, right? People that wanted to geek out around the technology and figure out how it worked. And you really couldn't do that much with one of these kit computers. Now, with the emergence of microcomputers, we also got some non-kit computers. This picture is from a French company called R2E, and they developed and sold the Micral N, which was, I think, was one of the first non-kit computers to be sold. It never became a big thing, but they existed. Now, instead, the big thing became the US Altair 8800. That is a hallmark of the era. However, there was like one big issue with the Altair. When it was delivered, and this was a kit computer, so you had to build it, it contained no operating system. It required machine language to be entered manually. And over time, of course, it improved. It did get an operating system. But because of this, you needed to know a lot about computers in order to use the Altair. Now, the big shift really happened with these two gentlemen. And what they did was they just made stuff up. Like, they just promised things they didn't have. So this is Bill Gates and Paul Allen, also known as Microsoft. Now, they saw that microcomputers required a structured way of programming them. So they told MITS that they had a version of BASIC, which was a prominent programming language then, running on the Altair. And MITS was like, yeah, cool, could you come demo it? The problem was that they didn't have a functioning version of BASIC running on the Altair. They didn't even have an Altair. So they had a friend who helped them build an emulator for another computer that they actually had. And then they built the BASIC inside of that emulator. And then went to demo it to MITS. And this is the part I find unbelievable about this story. It actually worked. The demo actually worked. The demo never works. That's like a rule of software development. So by some miracle, it actually ran. And Microsoft BASIC became the de facto standard, shipping with several different computers. Programming was now something that was not only isolated to the professional programmers. Programming now became for everyone. Everybody having an Altair, having Microsoft Basic or any other type of computer that ran Microsoft Basic could do programming. So now it was not only for business applications and space programs and wars. Now it was for fun and games and everything else. This laid the foundation for the modern software industry as we know it today. Now, with this, of course, there had to be another assassination attempt on our profession because we were getting too powerful. So in came the promise of 4GL languages, fourth generation languages. Now the idea of 4GLs was simply that we would make it very, very easy to program and thus reduce the need for professional developers. The approaches of the 4GLs were slightly different depending on which language you looked at, but the whole idea was to enable non-programmers to create powerful programs and make applications. So the prediction was that 4GLs would completely democratize software development, removing the need for developers. The 4GLs were supposed to enable business people and business professionals and domain experts to create the applications on their own. The reality was that the 4GLs were not very flexible, they were slow, and they were still pretty complex to handle. So it didn't really work out the way they expected it to do. And then the growing need for more complex systems and then the exponential growth in technology again helped us dodge another bullet. And not only that, it launched us into the golden era of software development. Because the 80s marked this rapid growth and innovation in our industry. So this was mostly fueled by the entrance of the personal computer. First with the PC in 1981 and then the Macintosh in '84. Now what the personal computer brought to the scene was it brought computing to the masses. This created a high demand for all types of software. Because the user-friendly environment and interface of the personal computers meant that not every consumer of software needed to be a producer of software. You could actually use a computer without understanding programming or without knowing how to program or for that matter knowing how the computer functions. So now all of a sudden we had an industry which had an imbalance between consumers and creators. So the demand was really high. In this era, we also got new languages and new IDEs. We got Pascal, we got C++, object orientation came on the scene, and companies like Microsoft, Apple, and Lotus really took off. But this also sparked the first idea of what I say would be considered a software developer, to contrast that with a software engineer. Because all of these abstractions and technology allowed engineers to move from simply being the builders to being the creators. Meaning that they would not only build and craft the programs, they would also come up with the ideas of what the programs would be doing. Developers were not only making software, they were inventing it. They were solving the user's problems with the technology that they had at their hands. New skills came on the scene like design, business thinking, project planning, and the profession became much broader than it had been previously. Developers were doing so much more than just coding now. So the 80s really formed a profession to much of what we see today. And just as we thought it couldn't get any better, we came on to the second golden era of software development. And this came with the emergence of the internet. So Tim Berners-Lee decided that it would be cool if there was a better way for computers and people to communicate with each other. And he created the internet. With the emergence of the web browser and HTML, the demand for software developers skyrocketed. Now everybody was launching the next internet product, the next cool .com startup. We saw emergence of e-commerce. Companies like Amazon and eBay came on the scene, which meant that our skill was in really, really high demand. and we got a bunch of new colleagues. Because now all of a sudden, all the ad agencies and print designers were becoming web bureaus. And with that, came the third assassination attempt on our profession. Probably the least serious assassination attempt that was ever made. This was the what you see is what you get editor and the Flash Macromedias of the world. And the only reason people tried saying that it would kill software development was because they didn't understand what we were actually doing. They didn't understand the complexities of the profession because they thought everything was just about building web pages. Meanwhile, we were focused on things like databases, UI, UX, but also psychology, because the name of the game in the 1990s was eyeballs. We wanted to attract as many eyeballs as we could to the websites, because we measured success in eyeballs, not in money. And this was also the downfall of the whole dot-com era, because all of a sudden, the investors that had poured bunches of money into all of these websites came back and said like, hey, where's our return on all this money we gave you? And you can't really monetize, or you couldn't really monetize eyeballs, so it all just came crashing down. And with this, we as professionals stood up and we swore that we would never build dumb shit without customer value again. No, we didn't. But it would be cool if we did. We did try. In comes agility or agile. So with Agile Manifesto, as a direct response to all the heavy ways of working of the software industry with the project plans and the Gantt charts and the requirement heavy work that didn't really meet customer needs. Now, for me, with Agile, a big thing was the shift from thinking about doing the work to thinking on delivering the value. But as we saw the emergence of Agile and these new ways of working, this also meant that we needed to start seeing our job differently. So with all of this, all of a sudden we now had to do things like clarify user demands and customer needs. We needed to negotiate our work, plan, design, in addition to building things. We needed to coach teams and grow our own skill sets because there was this huge emphasis on the continuous learning, continuous improvement. So software development now was a far cry from the computations that we were doing by hand in the beginning. So over this time, we just kept building these abstractions on top of other abstractions, meaning we got further and further away from actually doing the technical work into creating software. Now I only have two more things here before I'm going to move into what all of you want to hear about, which is the AI part of this talk. Now, the next thing, even though it technically didn't change the profession, it did do a huge impact for our industry. And this was with the emergence of smartphones. Now imagine that today, more people own a smartphone than people own a toilet. So with this huge explosion in devices that demanded to be filled with content, filled with software, also came a huge surge in demand for skilled software developers and skill set in order to build all of that stuff. Now, I live in Sweden, and I imagine it's similar in Norway. You really can't do anything. Everything from travel to banking to planning to communication is done through your smartphone. You probably, in the first 2 hours you wake up, interact with like 10 to 20 pieces of software just in your phone. So it maybe didn't change our working conditions or what we do every day, but it did really shape the demand for our profession. And the second modern day technology that impacted us was the introduction of cloud. Now, in the early days of cloud computing, there was a lot of jokes going around. It was like cloud is just, running your stuff on somebody else's computer. Ha ha, very funny. The thing is, we didn't really see back then what cloud would become now. We didn't really see what it was going to be about. Because the value of cloud was never the hosting part. It was never that I can outsource my hosting to somewhere else. The value of cloud, just like with early day computers, was the abstraction part. We abstracted away the complexities of what it meant to run scalable software. With product as a service and cloud native applications, we could now leverage already built components to do really cool stuff and accelerate the creation process. We had to focus less on the plumbing and more on creating the value for the users and the customers. Again, we shifted further away from our technical role and more into that role of the creator or the problem solver. So, now the code we write is even less plumbing and very much focused on doing these novel things that haven't been done before, to solving those business problems that haven't been solved before. And this brings us to 2024, the 2020s. So, it's safe to say that in the 2020s, the significant technology that everybody's talking about that's probably going to impact our profession the most is the generative AI. And specifically, when we talk about generative AI, we talk about its implications on productivity, in our context, developer productivity, but in general context, the productivity of many professions. So of course, we could view this as another assassination attempt on our profession. We now have generative AI, so software developers as we know it today are going to become redundant. Now, here's some numbers from a study conducted by GitHub. So what GitHub did is they took about 90 developers and gave 45 of them Copilot and 50 didn't get Copilot. And they gave them a well-defined task to solve. Now, with Copilot, 78% of the developers managed to finish the task. Without Copilot, we have 70%. That's almost the same. What's interesting was the average time to task completion. So with Copilot, it only took 1 hour and 11 minutes, but without Copilot, it took 2 hours and 41 minutes. Now, what's relevant to note, if you actually go and read this report, is what the task actually was. So the task was actually to write an HTTP server in JavaScript. Why do I think that that is relevant? Well, because there's plenty of HTTP servers written in JavaScript, so the training set for HTTP servers in JavaScript is really large. So the suggestions you're going to be getting when solving these problems are going to be really good. But still, hey, it's a 55% productivity increase. We have to acknowledge that. We have to say that that is pretty impressive numbers. But what's also curious about this is there's another study also done by GitHub, which means that depending on the seniority level of the person using Copilot, the accepted suggestions significantly drop. So with the seniors, they only accepted suggestions, the seniors accepted suggestions 27% less than the juniors. Meaning that you get less value from the tool if you are really good at what you're doing, or maybe you think that the suggestions the tool is providing aren't that good if you're really good at what you're doing. But if you're less experienced, well, from your frame of reference, the suggestions become really good. Now, all right, so we have this 55% productivity increase in the coding, in the actual solving of the program. What's interesting to me now is how much time do we actually spend coding, right? Because a 55 productivity increase in coding is only relevant if we look into the time we spent doing the actual programming. Now, these numbers come from a survey. It's a self-assessment survey done in a study with roughly 1,200 developers. These numbers are specifically for people that self-identify as software engineers. Now, first thing that surprised me here is that there's no slice called meetings, which I think should be there, but I'm guessing they grouped that into administration or brainstorming collaboration, depending on what type of meeting you were having. But still, it's almost 50% of the design and coding. That's not too bad. So we spent 46% on designing and coding. But then there's of course this other slide, which is waiting for tests and builds. And there's only one thing. There's only one thing I can show you in regards to that slide, and I have to show you this, which is classical XKCD. Number one programmer excuse for legitimately slacking off my code is compiling. So I wasn't satisfied by this. 46% designing and coding, what does that really mean? So I did find some other data on how coding really looks. So from the 46% on the previous slide, now I'm doing horrible stuff here. I'm smashing surveys together and different reports, and I'm well aware of what I'm doing. But just this is a mind experiment. What coding really looks like. So this is a study done by using software on people's tools, on people's computers, measuring what they actually do on the computer. Now, this study only looked, and this is very important, it only looked at 18 test subjects. So this is 18 developers over 740 coding sessions. A coding session is a stretch of uninterrupted time which was spent at the computer, so it's not a full working day. Now, 1/3 of these test subjects were professional developers, and the rest were students varying seniority levels, all the way up to PhDs and all the way down to bachelor's students. Now, 70% of the work is actually understanding. So 70% is actually just sitting and trying to figure out, what am I looking at and what am I supposed to be doing next? I don't know if this is affected by the fact that this study was done in Smalltalk, and that maybe takes a little bit more understanding. But they do claim to have similar numbers in Java. I'm not going to comment on that. But I think the point is clear. The actual writing of the code is not the part that takes up the majority of the time. It's the thinking part which takes up the majority of the time. I did also find this data, which was interesting, and this is data which has been gathered globally by a company that builds a tool that people voluntarily install on their computers, which measures how they use their computer. And this data set is huge. It's based on 250,000 individuals, 250,000 developers that use this tool that records their activity voluntarily. And it shows that the median developer only programs for about 47 minutes per day. That accumulates to 4.5 hours per week of actual programming. Like the most code-intensive people here, the 1%, do 4 hours and 20 minutes per day. So, given all of this, if we see this 55% productivity increase in coding, what does that actually mean? Well, I'm going to do some assumptions. Given all of these numbers, I'm going to assume that say we program somewhere between 2 to 4 hours per day, and the rest of it is spent in thinking and meeting and designing and waiting for code to compile, so 2 to 4 hours. So I have 55% productivity increase. Well, that means you get 1 to 2 hours of additional work per day. Now, is anybody in this room not able to fill 1 to 2 hours of additional work per day? I'm looking for, no. So most people in software are going to find things to do for the 1 or 2 hours additional per day, because the skill of a software developer is not only about coding anymore. Of course, we have the programming, we have the testing, we have the security, infrastructure, systems design, architecture, domain modeling, all the development practices, the problem solving. There's so many things we do that go into our profession beyond the actual coding part, beyond the actual programming part. So now we work in these cross-functional teams and product teams. Our job has not been to code for a very, very long time. Our job has mainly been to understand and to model reality in a way that it makes sense. Like most of us, we understand the businesses we are working for better than the business people understand the businesses we are working for, because we need to take those things that they say and make them make sense in a way that we can codify it into a program, into working software. So our job is to take user problems or customer problems and apply the latest technology to those problems in order to create cool programs and cool products that the users love. So that's the historic shift. Our jobs with time become less and less technical, and they're even less technical today for the vast majority of us. So with that said, let me give you another story from a different one from the one I told you in the beginning. So the year is 2035, and the sun is shining over the bustling city. Jacqueline slept in today for no other reason than she could. It's around 10 when she leaves her central apartment and strolls down to the Creation. The Creation is a co-working space where Jacqueline and like-minded creators meet every day to share ideas. As she strolls past the city square, it's filled with people. So the high level of automation in society has created an economy of abundance. Most people don't work or only work very little. Some, like Jacqueline, they enjoy bringing new ideas to life, passion projects. Some of them are sometimes profitable, some of them are helpful. Today is a special day because Jacqueline has had this idea that she's been working on in her mind for weeks. And just before she went to bed, she set all her AI agents on creating the idea. And when she woke up in the morning, the code was done. She hasn't run it yet, but she's bringing it with her into the Creation. It's supposed to be an XR application that is a time machine. It can take you back to any time in history. As Jacqueline enters the Creation, there's a bunch of people sitting around the old tree. That's a tree in the center of the building. That tree has been there for thousands of years, way before they built the building. Now, she grabs Mila and Kostas and goes like, hey, I want you to experience this with me for the first time, and drags them into one of the XR rooms. She loads up the application, taps her smartwatch, and the hollow projector in the ceiling just changes the whole space into the 1960s. Their clothes have changed, the furniture has changed, the whole vibe has changed. There's even music from the 60s playing in the background. All of the three of them are really impressed. This is Jacqueline's third product this month. Now, a lot of the products that Jacqueline creates never see the day of light, but some of the products she's built have thousands of users and are actually filling really cool needs in society. Now, the three of them decide that the best way to figure out what to do with this whole new idea would be to go for a beer lunch. So they exit the Creation and go to their favorite pizzeria for pizza and beer. Now, this scenario has one thing in common with the previous one I told you. It assumes a very high level of automation of developer skills. It assumes that we can reach to a level of AI where we can simply tell the AI what we want and it's going to do the job for us. Now the question becomes, what if we can't reach that level of automation? What if we can't get there. Now, this is something called scenario planning. So we have high automation on one scale and low automation on the other one. And then we have restricted access to technology versus accessible, meaning there's free access to the technology. Now, the first scenario we talked about, this is a high automation restricted scenario. This is a scenario where we do achieve a high level of automation, but the technology is restricted for use. Restricted can mean owned by one or a few companies, but it can also mean restricted in the sense that we can't run it. We don't have enough computer power or energy to run it, or the consequences of using that amount of computer power or energy are devastating to the planet. So it's just not freely available. Now, this scenario is the age of the elite supervisor, right? Because there's this elite that has access to the technology, and then there's everybody else. The second scenario we're talking about is still a high automation scenario, but it also assumes that the technology is accessible for everyone. It's accessible for everybody to use freely and accessible for everybody to do with what they please. So this creates something else. This is the age of the digital creative, because the focus now becomes on ideation. What can we conceive? Because the building is not a problem anymore. But there's also two other scenarios here. There's also this scenario, the scenario which I call the software worker. In this scenario, we don't manage to achieve high automation, so the reliance on people operating the technology is still high. However, the technology is restricted. It's owned by a selected few. It can only be used by a selected few companies or organizations. Now, these organizations have the advantage over everybody else trying to build something. The result becomes that if you want to create a piece of software, you're most likely to contract with one of these organizations that have the technology to build the software in the fastest and most efficient way. So most jobs are now found inside of these restricted organizations, making them able to drive down the wages of the software operators or the software workers. Maybe you're paid by the ticket or by the task. Work is planned somewhere else. You're not really involved in the problem solving anymore. And we've achieved perfect Taylorism. We've achieved the software factory. Other jobs will exist. There will be the artisan software development shops, just like there's craft beers out there. But these will be like the Carlsbergs and Heinekens of the world. So this is the age of the software worker. We've basically been reduced to industry workers. And then there's the fourth scenario with the accessible low automation. This is basically where we're at today. So this scenario is most akin to the way we work with Copilot and other automation tools today. We have automated software creation and are happily working together with the AI. There are our assistants. The technology is accessible for everyone, meaning that there's a level playing field. We don't see the difference between the haves and the have-nots that we've seen in the previous scenarios. However, we do spend more time on different types of tasks than we previously have. Maybe we spend some more time on creative thinking, on ideation, on looking at the code. So this is basically an extension of where we are today. This is, the second age of software craftspeople, if you will. So I don't claim to know what's going to happen. I don't even know if these are the correct axes to do this scenario planning with. But this is a tool you can use in order to make your own scenario planning, to figure out what you think about the future. Because once you've done this, you can start mapping out the skill sets needed to manage these different types of scenarios. For instance, in all of the high automation scenarios, we're going to have the skill set of supervising the technology. You need to know how the technology works, and you need to be able to supervise whatever it's doing, the same way we're supervising machines in other automation scenarios today. You're also going to have ethics, because machines don't have ethics, so that falls on you, the skill set of knowing what's right and what's wrong and how do we apply the technology in a better way. While in the scenario of restricted and high automation, well, if you want to have a job, you should probably look at AI and data science, because the few jobs that will be out there inside of the field will be all locked up inside of AI and data science. While over here, it's more about creativity and innovation, because we have the tools to build whatever we can dream about, but somebody has to come up with these cool ideas. On low automation, we still need systems design. We need to be able to design the systems and build them, and architecture, these types of ideas, because we can automate some of the creation, but like the bigger part of the function of the system still needs to be done manually. And in the accessible low automation scenarios, we still need to read and understand the code that's being generated. We need to know that whatever was generated is the correct stuff being generated before we allow it to go into production. And over here, it's a lot of classical programming, because not everybody's going to have access to the technology, and if you don't have access to the technology, you still need to have some classical programmers, so being good at programming over there is still relevant. Here, a lot of interpersonal skills, because in the accessible scenarios, we have more a collaborative approach to things. We work on stuff together, while in the restricted scenarios, well, we can imagine it's more a classical project management type of skill sets. So these are just all examples, but this is a very useful way of kind of thinking about the future, or kind of trying to break down the future beyond the hype articles that you read, that software development is dead. Now you can do your own scenario planning, you can plant your own axis, and you can create your own stories, and then try to figure out, if this is the future I believe in, how do I place myself inside of that future? So, with all that said, as you leave here, what should you do? Well, the first thing I want to leave you with is that I recommend everybody to make their own bets. And I prefer saying bets to predictions or theories or assumptions, because the way I view a bet is it's mix of data and gut feeling. So we have this incomplete data, but then we have a passion and a belief in what's going to be happening. I'm not big into sports, but I imagine if you do sports betting, you have your sports team, and there's some data around, some odds around what's going to happen in the game, but then you also have your belief in what's going to be happening, and that's the way you place your bets. And then as the game progresses, new data emerges and different things happen. And while you can't withdraw a bet, you can always make a new bet, right? So you can always bet on something else. And this is what I mean by taking bets. Because we take one bet today when new data emerges, doesn't mean we can't change our minds and make another bet as we go forward. We might have lost some time or money or something, but that's just the way it goes. The second thing I want to leave you with is that you actually work in this industry, which means that you can tip the scales of where we're going to end up. You see, when technology is open, it creates a lot of opportunities. We saw this for people that saw Dylan's talk this morning. When we have open technology, there's opportunity for a lot of people to get involved and contribute and do cool things. We saw this with the internet. If the internet would be proprietary, it wouldn't have had the same effect on society as it had. While when the technology is restricted, like the mega computers were, when you had to go to companies or industry or universities to use them, that creates a divide between the haves and the have-nots. So when it's closed, stuff becomes pretty miserable. When it's open, it creates a lot of opportunities. Now, now all of you actually do have the power to tip the scales. I mean, even if you don't have the power to do it yourself, you always have some level of influence. The way you express yourself, the decisions you influence or advise on. So, if you are fighting for a cause, let it be the free access to technology. Free access to technology. So with that said, the future, it's not written yet, and you can change it. You can affect how things will play out. So go out there and make the future you want to have. Thank you.
Welcome to the last session of the day. Do you have any more brain power neurotransmitters left to listen to me for an hour? My name is Billy Hollis, for those of you who don't know me, and I learned to write code in 1973. Would you care to guess what my first code editor was? It was punched cards. And so I did decades of primarily development, but in the 1980s I started getting interested in UX design as well, and read some books on the subject and really applied it, and that has become more important over the years, hasn't it? So I started learning about design based on my long-term interest in science. I actually went to medical school before deciding what I wanted to do. So I have a lot of science under my belt, and that has proven to be surprisingly helpful in understanding design, because we learned when I was in my programs about how the eyes and the brain work, and that applies directly to design. And that's important for folks like you, because traditional designers tend to take an intuitive approach to design. They work with something until it feels right to them. But see, I know developers, that touchy-feely stuff doesn't go very far with you. You need reasons for things, and very often those reasons are in fact based in science. Typically the science of the eyes and the brain, and pretty much everything we do, everything we experience is tied into how we see and how we think. And that includes, of course, the devices and software that we use. Now, these factors have been investigated for a long time, many decades. I learned 40, 50 years ago about some of these things, and the research has continued. In fact, some of the research I'll talk about today was done 100 years ago by German scientists. So we've got a big reservoir of that. There are a lot of studies, and I could reference those, but honestly, that would be pretty boring. So instead, I talk about the science of vision and cognition via demonstration. In many cases, sort of exposing your own brains and visual system to something so that you can see how it works without the boring detail of studies. Now, it's possible, most of you probably did this, you know that there's some science there because you did things like the blind spot experiment. Did you do that in science class in school? Most of us did. That doesn't really apply much to software, though, because you have to really work to realize the blind spot. The blind spot is the part of the retina where the optic nerve comes in, and there's a little area there where there's no sensation, there's no vision. But then there are things that are kind of common sense that we know about. For example, our visual system is tuned to filter out clutter. If I show you a picture of seashells, you don't really perceive that as individual seashells. It's just a generic field of clutter. And that certainly has application to some of the things in software. But in general, those are obvious, but there are some scientific things that affect how people see that are counterintuitive. Let me show you one. You see this? You see that bar in the middle there? That's actually all the same color. It looks darker to one side, to the right side. You perceive it that way, but in fact, that's not really what's going on. Let's see if I can bring this up and get it over there. I have some demonstration programs for a lot of this. So I've got this in gray and in blue. Let's do it in blue. It's basically the same general effect. So I've got this, you see this right here? This is a blue square, and I can drag it around. But it matches wherever I drag it. Now, you believe that I'm not changing the color as I move it back and forth, right? So the lesson from that is that color is perceived in relation to colors around it. There's actually a very famous optical illusion around that. Let's bring that up next. Some of you may have seen this one. This one has been on the web a long time. You seen that one? For those of you who haven't seen it, the square with an A in it is the same background color as the square with a B in it. But your eyes are not seeing it that way. Your eyes take into account light and shadow and things like that. So that, and we can prove this because I can go and, where's my little, come here. Oh, my mouse is giving me a little trouble. Are you ready now? My mouse has been acting silly. I guess I'll use my touchpad. See if we can get down here. And come on, I need to make you bigger. All right, then I'll just make you as big as it's possible to be. My system seems to be hanging, and I don't know. Oh, there we go. Where's my square? I'm getting really odd results. Let's start this over again. And I still don't see it. I have a little draggable thing, but it's not showing. And you know, I've done this demo 100 times, and I don't understand why it decided not to show that. So, because I've got a draggable thing the same way I do for the blue thing, and I don't really get it, why that's. Let's see if I can get it over here to work. It's just not there, and I don't know why. So you'll have to take my word for it that in fact, when you do that optical illusion there, that those two squares are in fact the same color, and that comes kind of from evolutionary reasons, where you need to be able to recognize threats, whether or not those threats are in the light or in the shadow. So so your eyes automatically adjust. Now this has certain implications for design and user interfaces. For example, you don't really need very bright colors for the visual system to sense them. One of the common mistakes that developers make when they develop UIs where they start applying color for the first time is they make the colors far too bright. They don't need to be bright for people to pick them up. And bright colors set off some alarm circuits in many cases in the brain, so they stress people. So you don't want to use bright colors for a lot of your signaling. So all these things about the visual system are there for some good reasons. Our ancestors needed, as I said, to recognize a threat in sunlight or shadow, and because of some of the clutter elements in the environment, we tune out things that we sense are not important right now, and the visual system emphasizes things that it considers to be important, threats in particular. And notice the bright colors there. Bright colors tend to indicate threats. That's why we don't want to use them continuously, because they tend to stress the user. We have pretty good color vision, and it's pretty subtle because as omnivores, fruit being a big part of our diet, then we needed that vision, our ancestors have in the past, to be able to tell when a fruit was ready to consume. You eat fruit that's too green, it makes you sick. And if it's too ripe, then it might also make you sick. So we evolved some of that color vision in order to work to be able to consume fruit, whereas predators tend not to have great color vision. They tend to have vision that's more based on motion. So that's why we don't want to use bright colors too much, and we can do subtle things. So that kind of understanding of the science is the foundation of giving people good interfaces. If you don't understand some of the principles of how people are seeing things, then you're just kind of fumbling in the dark. You've got A/B testing. Well, yeah, but why did people pick A over B? If you understood something about how they were seeing it, you might not have tried B in the first place. You might have realized that A was better and tried a variation that was a C choice that was even better. So you'll get better designs faster if you understand what's going on with the visual system. So we've already seen, because of the way we see color, keep themes neutral, and when you use colors to signal, don't make them too bright. So this is an application that my team wrote in 2008, when some of these new technologies to do very nice visuals were just coming online. And notice that the overall color theme there is pretty neutral. And that allows things like the sticky notes to stand out very, very easily. And even the sticky notes, though, have a reasonably subtle color. They aren't bright yellow. You wouldn't want to do that. And this looks kind of stale to me now, but in 2008, it looked very good, but more importantly, users liked it. I continued to get feedback regularly from people. The English phrase that they would use is, "That's easy on the eyes." I'm not sure if you have kind of a similar phrase or if that translates well, but I heard that over and over again. And color can be useful, as I said, for signaling. It doesn't have to be too bright. In this case, this is a contacts list, and the user is interested in how long it has been since they have talked to these contacts. Well, we've got days and months and years there, but we color months a fairly subtle yellow and years a fairly subtle red to indicate that that might be potentially of more concern than if it's just been a few days that we've seen them. And that illustrates a general principle. You want to present data to the user to minimize cognitive effort in the way that they would like to see it. If they're interested in how long it's been, that's a time span. They're not really interested in the date of the last contact most of the time. But that's what's in the database. So a naive developer might just stick the date up there. And now you are overtaxing the cognitive system. And they go, oh, I saw them in February 9th. Well, let's see, March, April, May. You're doing arithmetic in your head, and that is not really what you... Computers are a lot better at that than you are. So reducing cognitive effort is one of your goals as you design user interfaces. I'm going to revisit this screen a bit later. But not everybody kind of gets it. This is a drugstore app for an American drugstore chain named CVS. And they're my drugstore. They're just way too bright. And they've recently changed this. I shot this screenshot last year. But they're still brighter than they should be. Somebody there said, our corporate colors are bright red, so you have to inject that into the app. Well, I guess branding people really love to spray their colors around, but I don't like it, and I think a lot of other users don't like it either. They don't realize, I think, the side effects of what they're doing by putting those bright colors into their app because they don't understand the science of how people are seeing it. The biggest disaster that did things like that was Windows 8, which was just waving a flag, basically. Look at me. I'm cool. I'm colorful. And that was just, and the people at Microsoft did not get this basic science and didn't realize that putting all those bright colors, and as we will see later, sharp edges, putting all those things in there didn't really work well with user brains. Now, there were plenty of reasons why Windows 8 failed, but those subtle, unconscious reasons that people felt when they saw the screens, that was one of the big reasons why it failed, is it didn't feel good to people. Those sharp edges, I mean, edgy, well, Microsoft was trying to attract attention and look different from the iPad, but that doesn't mean it was a good idea. And I told them that in the beta period, and they just waved me aside. No, Billy, you don't understand. We've done our focus groups. Everything is going to be fine. Well, we found out about that within a few months, didn't we? When the president of your company gets fired over a disaster like that, you can call it a disaster. Now, in addition to color, our visual system is also optimized for seeing and interpreting shapes. And that, I find, is an underused capability in software, mostly because it's a lot easier to do it with today's platforms than it was, let's say 15 years ago. So, for example, here's a status indicator for one of the applications I worked on for cattle management. We had to indicate whether a cow was alive or dead. Well, we could have just put a checkbox there, or the words alive or dead. But it turns out that the fastest way to get that into someone's brain through the visual system is to have an evocative shape that symbolizes that status very clearly. And interestingly enough, because I teach classes to my clients before we begin designing systems, interestingly enough, the idea of turning the cow upside down came from a developer on the design team. That idea did not come from me. Going back to that screen we saw a few minutes ago, notice its use of shapes. I wrote this to sort of indicate some possibilities to a client, about 12 years ago, just to kind of break them loose from conventional thinking. And the smiley face, for example, or the frowns, if they're not happy, that comes out of the science that we have a special portion of our brain for recognizing facial expressions. Did you know that? We are optimized for that. Therefore, if we put that kind of minimalist face into an application, the time it takes for a user to see that and interpret it and understand, they're not happy, but they're pretty happy, that is a very minimal amount of time. The smiles and the frowns are actually reflecting a number. I've got the demo app. Any of you can have it if you'd like it. If you hover over the frown or smile, you'll see a number between negative 100 and positive 100. Does this one have? No, it doesn't have anybody with that. If it gets really negative, some angry eyebrows appear to really let you know that one's really upset. And shapes, notice that they're fairly minimalist. We can layer shapes on top of one another. There's the universal symbol there for a physician to indicate that contact is a physician. And the visual system is tuned to sort that out, because in the real world, things do overlap. And we come from fish who are underwater. There's translucency and transparency in the water. Our visual systems are able to interpret that very well. So using translucency and overlays and things like that is a good way to leverage the power of the visual system. In addition to that, we can stay pretty simple and minimalist because the visual system is tuned to fill in gaps. We don't need to have to see the whole leopard to know that it's a threat. We only need to see part of it, and our visual system will fill in the rest. And as a result, the shapes that you use can be very simple. That's why we tend to have minimalist icons. The designers kind of figured that out through experimentation. The icons do need to be evocative and understandable, and that leads to a problem that you do have to watch. I don't know how much longer the camera icon is going to work, because nobody uses cameras anymore. They all use their phone. And then you've got icons. If you notice on the right side of the screen there, the other income section has what I consider to be a very evocative icon for other income. Do most of you recognize the reference there? Yeah, you see it instantly and it makes sense. What would be another possible icon for other income? I can't think of one that's any better than that. So it's very, very simple. There's not really much to it, and yet your visual system hooks that in your brain to a character on a TV show. For those of you who are wondering what I'm babbling about, the TV show is Breaking Bad, and the main character is a drug dealer. That's the way he makes his income. And that's kind of what he looks like. Now, shapes are powerful for the visual system. Even if they don't have precise meanings, the meanings can be learned, because the visual system just knows how to pick them up very, very quickly. So imagine that we've got an application where there are trucks going out of a facility, and each truck has loads from multiple locations. So the first one there might have 4 loads for different locations, and the next one has 5, I think, doesn't it? Yes. So a triangle might represent a warehouse, and a circle is an office building or something like that. So there are different shapes for different things, and you have to learn it. And in that particular application, there's a hover, so first-time users will understand the meaning of that. But that's basically a parent-child relationship there. We have one truck and many loads. Here, I'll actually show you the working version of that software to get a little better idea. All right. There it is. Hang on. I'll get it over there. There we go. Okay, so you can, and I randomize the data every time. So if I put that up there, we already kind of know the circles and the triangles, and I've got the hover there. And if I hover over something, you'll see something about what that is. Right? Did I get in there? Come on, get in there. My touchpad's not that. There we go. So we've got hover, and we've also got the ability to expand. But what that allows the user to do is very quickly scan that left-hand column in order to find out some essential information about the loads that are on any individual truck. In particular, something about whether they're going to be delivered on time. Which of these trucks do you think have some loads that look like they're at risk of being late? The red ones. Say, and how did you know? I didn't train you. How did you know? Well, that's just intuitive, that the color signals that there's a potential problem. So as you scan down, you can look at a shape and realize, oh, that represents a potential late problem for that load, and it's going to a warehouse or a dock or whatever. And then the app has built in the capability for, if I want to know more about those particular loads, then I can get down and get more detail. And I can even, it turns out there's yet another layer. If you click on a load, it brings up the map for where that load is and such. So that's a design principle that's called progressive disclosure. It's not really in the visual family, so I'm not going to talk any more about that today. I'm having a hard time getting my cursor to behave. I should have rebooted my system, I think. I'm not sure, but I think the problem might be, honestly, where's my cursor? Oh, there it is. It's not wanting to come over. I think the problem might be, I can see right here, Windows wants to update. And I didn't do that. You can't see it. It's on this monitor, but Windows wants to update, and that's, I think, giving me some grief. This is Windows 11. I can tell you many design flaws in Windows 11. And I'm very disappointed that Microsoft didn't learn some lessons from their earlier mistakes. So users pick up what's going on with shapes much faster than text. And if you do have to have text, you need to leverage the visual system by putting some structure into it. And if you put jargon in, now you're kicking in the need for more cognitive effort to interpret the text. So that if I've got this, well, even to an American audience, that doesn't make much sense, but if I format it the way Americans do telephone numbers, it's much easier. You might guess what that number is, but you'd be a lot faster at guessing if I did it like this. That's a credit card number. But the jargon problem certainly is something that you have to contend with. We as technologists tend to use jargon. Our users often don't understand it. So you could imagine a typical warning that somebody puts up about the OAuth token is not valid, it may be stale or corrupt. Well, users kind of just gloss over that. Cognitively speaking, they don't want to expend the effort to understand what you're trying to say there. I've kind of translated what they perceive out of that, and it comes out to something like this. It's gibberish because they don't really know what it's saying. The basic message they get from it is, whoops, sorry, I hit the button by accident there. The basic message they get from it is, do I want to do the thing that am I going to just go forward or not? They don't really get much out of it besides that. It's like, do you want to go ahead? Yes or no? And so understand when you put those kinds of warnings in front of users, you are taxing their cognitive systems to the point that you're risking that they just ignore anything that you have to say. So all of these things about how the eyes work and how the brain works yield something called design principles. They're really guidelines about what makes a design good or bad, not absolute rules for sure. But if you understand those design principles and respect them when you're creating user interfaces, then you'll avoid some mistakes that make interfaces harder to use. And they're based in how the visual system and the brain work, well, kind of whether you like it or not. So let's see an example of that. How many of you have seen a video with two teams passing basketballs, one dressed in white, one in black? Hands, please. How many? How many have not seen that video? Okay, that's about 2/3 of the crowd there. So I'm going to show that. It's only about 20 seconds. And those of you who have seen it, see, you have to be quiet. Yeah, you got the idea. So that we don't give away the lesson that people are going to learn from the video, because you have to focus. You have to really focus on the video to be able to fully understand what it's doing for you. So let me bring that up. Where is that? Here we are. Yeah. This is the basketball awareness test. Let's put that to full screen there. Come on. And let's play it.
This is an awareness test. How many passes does the team in white make?
Watch carefully now. Okay, how many passes did you see? 13? Most people see 13. There's a little bit of ambiguity, but most people do see that. But that's not really what the test is about. Did you notice anything unusual or unexpected in that video? Anyone? What did you see? Out loud, please. You saw somebody walking through, or I'm sorry, I absolutely can't hear you. The monkey, or something. A monkey. Did anybody see anything look like a monkey? Did you guys see anything look like a monkey? No? Well, let's watch it again.
The answer is 13.
This time not worrying about the basketball.
But did you see the moonwalking bear?
Now, it is perfectly normal not to see that. I was at one training class in Idaho with 15 developers, and not a single one noticed the moonwalking bear. So what's going on there? Why does the visual system not see that? Well, what I did and what the video does is it gets you interested in something else. It primes you to look for the basketball, and it turns out that your visual system doesn't have a lot of bandwidth for seeing the entire visual field. That's just simply not the way it works. In fact, the area of high-resolution video is comparatively small. If I take this bottle cap right here, where'd that bottle cap go? This, and I hold that out at arm's length, that is roughly the amount of high resolution that we have in our visual field. And what our visual system is doing is constantly moving that around to what it has decided, that another part of the brain has decided is important. So when you give someone a task, that part of the retina, it's called the fovea. Some of you may have learned that term in biology. That part is constantly shifting around based on what the brain thinks is important right now. So when you set a task for someone, then you determine what their visual system is going to pay attention to, and it filters the rest out. It simply throws it away. And that's built into the visual system, and you really can't change it. Let's do another test, now that you even know that exists. So I'm going to show 3 slides, each for a few seconds, and they will have drawings of common tools that you might find around your house or workshop. The task I set for you in this case is, how many of these 3 slides contain a hammer? Now, I'm only going to show each slide about 3 seconds, but people generally don't have any trouble seeing the hammers. You ready? How many slides had a hammer? 2? Correct. The first and the third one, the middle one did not. But now if I come back at you with a different question and say, how many pairs of pliers did you see? Or scissors? Or wrenches? You have no clue, because that was not set. Your visual system basically filtered all that out as it searched for, I mean, your visual system kind of got close to that, or maybe even went right over it, but because it wasn't what you were interested in, it just got filtered out. Here, I'll show you the 3 slides again, and you can see that, yeah, there's wrenches and pliers, scissors, yep, all over the place. And yet you didn't even notice them. So that is a design principle called inattentional blindness. It shows us that users are primed by goals. And that's not the only example of that kind of priming by goals that science has discovered. Usually when users go to a screen or a view or a page that you create, they go there for a reason. They have a goal. So one of the implications is, since the goal heavily influences how they see things, you should understand what the likely goal is when you create that view, because it's going to heavily influence how people perceive it. They will look for things related to the goal, and they'll filter everything else out and make the things related to a goal easy to find. That's good design. So as I said, inattentional blindness is an example of a design principle, that one that concerns the fact that we don't have a lot of high resolution. And again, let me emphasize, this is built in, so you can't really train around it. What people learn to do after a long time, if they've got a really crowded screen, is they train their eyes to kind of move to the things they care about, and they just filter the rest out. So if you're putting things on the screen that they don't care about, you're just making it more difficult for them to learn how to find the things they do need. That's one of the reasons why you don't want crowded screens. Another set of design principles are called Gestalt principles. You see them listed there: proximity, similarity, figure ground, continuity, and closure. And there are some others we don't have time for. And then that entire set of principles is based on our visual system, and I'm going to show you those in just a moment. There's also some design principles that are based on how the visual system coordinates with the rest of the brain. And those design principles are called archetypes and familiarity. Basically, sometimes experience influences what the visual system sees. You may not know this, but they've done studies of tribes that don't have buildings, hunter-gatherer tribes that don't have buildings. They have a very difficult time realizing if they see a door at an angle, they don't realize that it's a rectangle. They don't have the experience tied in for their visual systems to rapidly see that. So the experience ties into the visual system and helps it recognize things. As I said, inattentional blindness is one of them, and you can kind of see the idea there of the coin held at arm's length and filtering out anything that is not related to the goal that you see. So, for example, let me show you this screen right here. This is a kind of my spoofed up representation of a typical screen in a, let's say, not a 2005 app. Some of you probably have screens that look like that in your apps today. I see some nods that, yep, we've got some. Well, I left that screen up for about 4 seconds, and I didn't tell you anything, so you probably didn't notice this, but let me bring up my demonstration thing. So now let's get over here. So I have a little simulation that I wrote of the effect of the fovea being small. Did you notice, by the way, I left that up about 4 seconds. Did you notice who the screen was for, the demographic information in the upper left-hand side? Did you notice that? I mean, now that I've told you, of course, you go, yeah, that's Sherlock Holmes. But this simulation, I've put a little circle showing roughly the amount of high resolution that you actually see, and I've blurred out everything else. But I can drag this around, and I will bet not maybe one or two people in this entire crowd noticed that, in fact, once you start to wander over into the rest of the screen, the stuff there is absolute gibberish. It doesn't mean anything. Look at the labels there. Oh my goodness, they're cramming more stuff in here. What is a Fisher table, or a Dingleplop, or a raster possum? See, you don't realize all that stuff is over there even though you saw the screen, because you didn't have any goal to find that out. You didn't even have a goal to find out who Sherlock Holmes was, so it was just clutter. It was no better than the shells on the beach to you. It was just a bunch of clutter. And that's one of the reasons you don't want to use crowded screens. If people don't have a clear goal and be able to find the information related to the goal, all that other stuff that's not relevant to their goal is just clutter. It just gets in their way. Oh, there it is. Yeah, and I've got a copy in the slides so you can kind of see. Be reminded if you get a copy of the slides. Sometimes the expectation of seeing something, that's called priming. And there are several forms of it. Inattentional blindness is one, but there are others. Let me show you a real case that I ran into. I was at actually an NDC conference in Minnesota a few years back. And I needed to go uphill to get to the conference center, and I was close to a parking garage that had an elevator, and I had walked down to get to the coffee shop, and I didn't want to walk back up 4 or 5 stories. So I went to find the elevator in the parking garage for the convention center to go up. And I want to go to find I found the elevator area, and I walked up to the elevator. Now, let me first ask you, from an expectation experience point of view, what do I expect an elevator button to look like? The thing to call the elevator, what shape do I expect that to be? It's almost always going to be round. That is an example of something known as an archetype. We expect elevator buttons to be round. They're not all round, but that's kind of our initial expectation. So I find the elevator area, and I walk up, and I see this. And I walked right up and punched that round thing. But what I got was a security guard on the speaker saying, "Yeah, what's your problem?" He sounded pretty bored too, because I think maybe a dozen times a day somebody comes and makes that mistake. Why did I make that mistake? Well, because I'm looking for a button that's round, I'm close to an elevator, and I'm thinking about something else. So we're going to talk about this a little bit more detail later. Distractions are just ubiquitous, and we don't need to create our interfaces that you have to be completely focused in order to use them. So when I looked at that, now we can kind of see it in detail, and there's a little bitty thing, emergency call box, which I filtered right out because that wasn't part of my goal, you see. And then if I get back far enough, I see that there is an elevator button to call it. It isn't very obvious. It doesn't stand out that much, not much contrast there. But I did manage to get on the elevator and get up to the next floor. So that kind of priming, and also a related thing, what's called framing, your experience ties into what you perceive in very dramatic ways you might not realize. They did an experiment with some people going through model kitchens, and they didn't tell them the real purpose of the experiment. There were like 7 or 8 of them. 2 of those kitchens did not have stoves in them. And they got at the end and they asked the people, "What did you think of the stove in all the kitchens?" People remembered seeing stoves that didn't exist, because their experience with a kitchen is that it's got a stove in it. So their mind just filled that in. And people are also influenced by the concept of habituation, that ruts get worn in the mind, grooves get worn, and the visual system doesn't, it just kind of goes to sleep on some things. Let me show you, I've got my little, I've got my example of that. Let's see if I can bring that up. I've already got that there. No. So that's this. Let's go back over to that and put up a little screen that represents kind of workflow. I've got to shift it over there, don't I? So suppose we're working on some kind of a workflow and there's some stuff we've got to do for the first step. Actually, no, I've got to start this all over again because I was playing around with it and it obviously got some things incorrect. Am I going to have to start the whole program over? I am. It's maintaining some state that I didn't want it to maintain. It's just a demo program, so made a mistake there. All right, let's close you down. Come here. And restart the base program. Yeah, there it is. All right, sorry for that little delay there. Let's try this again. There we go. Now we've got it right. So we've got this little workflow thing, and we've completed the first step, and we go to the next step, and we got another step in the workflow. So we do whatever work we need to do there, and we click to the next workflow step, and we've got yet another step, and we complete that, and we get to the final thing, and we need to get done, and we press the button that's down in the same place that the next buttons were in all the three screens, and we just throw away all the work we just did. And you think, all right, that's stupid, Billy. Nobody would ever do that. Nobody would ever write software like that. Well, I give you American Airlines. I'm going to show you some sample screens that I took one day trying to book a flight. Now, they did eventually get rid of it, but this is the way it was when I captured these screens. So I have done 3 screens so far, picking my flights and taking off, And now I'm at the 4th screen, and I filled in some things at the top, and I think, okay, I'm done with the 4th one. All the other screens have had a continue button in the lower right. All 3. So I'm just, as usual, I'm not really paying that much attention, and I go down to the lower right and press that button that says Start Over, and throw away everything I'd done on 3 screens. Why did it appear that way? Well, it turned out that I had not yet filled in the credit card information, and so it can't continue. So some designer decided, well, it certainly looks nicer if the buttons are always right aligned, and of course we don't show buttons that can't be used right now, so we're going to get rid of the continue button. In fact, if you finish things up, it looks like this. But I had to go back and re-enter all 3 screens of data in order to get to this. Your visual system also takes context into account based on what you see, what you kind of expect to see. If I tell you on the next screen that it's the map of a campus with some buildings and streets, then you see that, and okay, yeah, looks like a campus there. But if I tell you, well, actually, there's a word embedded in the buildings. Did you feel your visual system shift as the context and expectation shifted? And those letters embedded in the buildings is an example of something called figure ground. Some of you, if you've had art classes, you may have seen that. The idea that the brain chooses what part of the visual field is important right now. and it interprets what it sees based on that. So in this particular case, this famous diagram can be interpreted two ways. And different people see different things. What did you see when you first looked at it? Two faces? Who saw something else? The outline of the vase? Yeah. So, and now that you know both of them are there, you can actually shift the perception to that. So that's an example of figure ground. And again, you say, well, what does that have to do with software? Aha. Well, here is from an application we wrote in 2008. We were working with some of the translucency and the things that we could do. So we made it so that if you're on a main screen, you're on a parent record screen, and you want to edit an address, okay, we're going to bring up the address, but we're also going to make the parent screen smaller and grayer, like this. What that does is then tip off the visual system to what is important, the figure. The figure changes from the main parent screen to the child screen. We're directing the user's attention to that. And then when we're done, we put it back the way it was. And we did that in 2008. About 2015 or 16, when HTML5 came out, we started seeing websites do that. This is a Twitter from a few years back. And it's got exactly the same effect, although I have to admit they did it better. But we should have made the gray darker. But that is a way of minimizing the effort people have in remembering where they are and what they should have to focus on. And especially if people get interrupted, coming back to something like this, the time to get back into the context of what it is you were trying to do, well, that's minimized because the context is clearly, I had the parent and I'm doing something with the child in front of it, with the entry window in front of it. Though that's an example of human limitations. And they're just, again, built into us. There's nothing we can do about it. We just don't see everything in the visual field. That's what inattentional blindness tells us. And now what we're discussing is this idea that attention is a scarce resource, very scarce. We just have a limited amount of it. Short-term memory has limited capacity. If I ask you to remember a 3-digit number, you're going to do a lot better than if I ask you to remember an 8-digit number. That just is because of the limitations in short-term memory. So those limitations play into why the figure ground guiding attention is beneficial. It minimizes attention and minimizes short-term memory. You don't have to think, oh, what was I doing? When I come back from like the telephone that rang or something, and I come back to the screen, I don't have to think, wait a minute, what was I doing? The figure ground shows very easily and quickly what I was doing. So let's see this in more software terms that's more typical of the kind of stuff that you would write. So modern, I shouldn't say modern, that's not the right way to put it. Traditional business applications. They tend to have menus that more or less mirror the way the programmer thinks about it. You know, there's data and features. So there's file maintenance screens and there's screens that do things. And so the menus are kind of created around those features and that data. And that's not really the best way to do it, but that's the way a lot of systems are done. So that let's suppose that in this, and this is taken, by the way, from a real project I worked on. Let's suppose that the user, every morning when they come in, has to go through a series of tasks. They have to, this is for the cattle management people. They have to make sure that all the cattle are assigned to the right pens. They have to check to make sure that if there are any changes overnight in where the cattle were put, that that's entered into the system. Because the cowboys don't do that. And then they have to check whether the feed costs have been allocated properly. And then they have to check, what is another thing? Whether or not they have to import some information from the veterinary system to see whether any cattle have died. And then they have to go do some billing for commodities. Okay, so there's several things they have to do. Now, it turns out that because of some of the file imports, and the later things they have to do it in order, or the system will be messed up. And it's a lot of trouble to unwind the problems that they've done. Well, the software as written, this is spoofed. But this will be familiar, I think, for you in some of the applications you've seen, that to do those separate steps would be different places. So if we want to figure out where the cattle are, or get them in the right place, then we go to this menu, location management, cattle pen transfers. And then we get ready to do the feed stuff. Well, that's a different menu, a different place. And then we want to do the vet import. Well, that's way over here, and import the vet charges. And then we want to do some stuff with commodities, and that's here. Now, notice that in order to carry out that workflow, because that's what it is, the user's now going to have to memorize a fair amount of stuff. They have to learn and understand, and they have to do it right. They have to do it in the right order, or they're in trouble. Well, that's really a problem for the users, because number one, when you do it that way, the user's attention is split. They have to use some of their attention just to navigate through the system, rather than, you want as much of the attention as possible focused on the thing they're doing, the task at hand. So the attention was split, and the short-term memory is strained, because the user is having to track, which tasks have I done? Which ones do I need to do? Instead, we should apply a design principle called recognition over recall. We don't want users to have to recall where a task is accomplished. Just give us one place where we can do all the tasks. And they shouldn't have to track in their minds whether the task has been completed. So what that means is, ideally, the users should just recognize the next thing they want to see, need to do off of a list, instead of using recall, having to know where in the menu option it is. And the interface should remember whether a task has been completed. So we might end up with something like this. We've got, okay, and it's we'll talk about the big thing on the left there. So we've got for each day, we put in the cattle movement. And notice that once we've completed that step, we hit the check mark, and it goes gray. So that lowers the amount of effort we have to do to track what's been done and what has not. And there are some hints there about whether or not things need to be done. So the vet charges are coming up. That's pretty important, because there's $1,500 worth of charges that need to be done. And the cattle movement might have a warning. Maybe those 2 unposted deaths mean that you've got something extra that you're going to have to do when you carry out that step. So you can walk down through the steps, and each step will take you to the appropriate screen to do things. And steps further down that weren't possible yet would also be disabled until the step they depend upon is done. So now we're guiding the user through the exact same workflow as before, but we are leveraging the recognition over recall, so that the attention that they have to put into it and the amount of memorization they have to put into it is dramatically reduced. You can also be primed by past experience. I talked about the elevator button problem a few minutes ago. And experience, people can eventually learn complex stuff, even if it's incomprehensible when they first look at it. But if past experience is kind of commonly shared by people, then we kick into this idea of archetypes, things that we expect it to work that way. We expect elevator buttons to be round. And that's just one of many kinds of archetypes that we can put into software. This is an elevator panel. And when I first saw this, something struck me about it. I often ask crowds, audiences, when I have lots of time, what do you see about this that seems odd? And the usual developer answer is, there's no floor 13. Well, that's the analytical portion of your brain at work there, isn't it? But that's not what I noticed about this panel. What I noticed is that the paint on this placard is worn off. Why is the paint worn off? Well, because people are pressing that with their finger, thinking it's an elevator button. Why do they think it's an elevator button? It's round. So again, people don't scan around and look by default. Eventually, they pull back and kind of figure it out. And I think it's kind of funny, because once people are doing that with the ground floor and spraining their finger. They've already been in this elevator once to go up to their room, and now they're going back down. And they're still getting it wrong. So that's an example of misuse of archetypes. And that's not just an isolated example. I also saw another elevator showing the same problems in Las Vegas. And I actually got on this elevator, and I was on floor 25. There was a guy standing by the panel, and he said, "What floor do you want to go?" I said, 25. He punched the button for 24. And, "Oh, I'm sorry, we'll have to stop." I said, "No, that's all right. Now we've got to go at 24 floors." So I gave him a lecture on elevator design, elevator panel design. And as always, I try to sort of communicate that over to software. This is a screen that I captured at a Marriott in Pennsylvania, where this is exactly what it looked like when I came up to it, and I wanted to get on the internet. So there we are, high-speed internet. Let me click that, because boy, that looks like a button, doesn't it? Well, it's not. When I pulled back, this is what the whole screen looks like. And the button does, in fact, look almost exactly like that header. Don't make your column headers look like buttons. There's a misuse of archetypes, and you're causing extra cognitive load on the user to have to sort that out. Experience can be leveraged in many ways. This is an app that we wrote for a propane management company. If you are in the industry of propane and fuel, then you know that propane is green, and you know the shape of the tank that it's in, and you know kerosene is red, and you know the shape of the tank that it's in, and so you don't have to be trained on that your visual system interprets that very quickly based on your experience, tying in your experience to your sensation. So let's go through a few more principles. I promised you the Gestalt principles. Here's I like to show when I mess up, because that's kind of indicating that that lots of people would mess up. This was in a hotel that I was in. I'm coming in about 11:30 at night, very tired. I'm in room 207. I see the range, 201 to 223, and see the arrow right below it, and I take off in that direction. But that's not the right direction, as I found out pretty quickly. If you go back, you'll see this. Now, why did I make that mistake? Because the closest arrow to the range of my room is that one. And the eye automatically groups things that are close together. It assumes that things that are close together are related in some fashion. They should move those arrows down a little bit, and that sound would be a lot better. And Amazon made the same mistake on a shopping page, where I saw this very item here, this USB flash drive, and decided I wanted it, and I went, and where's my thing here? There it is. I went and did check the checkbox down below it. You see the one? Can we see it over here? The one that's down below it. And in fact, you need the one that's above it. But that's further away. So I made that mistake. When I went to the shopping cart, the item was not there. The Gestalt principles are based on structure and relationships, and the human visual system's optimized for that. And there are stages of processing that indicate when the Gestalt principles kick in. They kick in unconsciously in about a quarter of a second right after processing inside the retina. And then stage 3 is when some of that experience stuff gets applied that I talked about earlier. So we saw Gestalt proximity, and if you get things too close together, one of the implications is that you're more likely to make errors. There's the edit button, and it turns out that the edit button throws a lot of work away. And then the edit button for regular editing, and then this throws away your work to start over, and it's right next to the edit button. Silly. Also, the proximity principle sort of kicks in here too, because look at that. You see floor 4? It's got some braille on it. It's hard to see. Suppose I were a blind person and I found floor 4. Which button do I press? Well, that isn't obvious at all, is it? So proximity kind of works inside your mind this way, that Do you see rows or columns of stars in this grid? Rows, yeah. How about this one? You see columns, but that's the same size grid with the same number of stars. Do you see rows or columns now? Typically see rows. The color overrides the positioning. That's called Gestalt similarity, similarity by color. And you can also override with shape and size. Here, since I'm running out of time, I'll get to this. Typically, you'll see rows there too. All right, and we can leverage that in software in ways like this. If you put data on a timeline like this is customer interactions. Notice that things that happen close together in time become close together in distance. And the proximity principle kicks in and says, I bet those customer interactions are related. Maybe they did a service call and there's a payment for it or something. All right. All right. I have a few more things that I'm not going to have time to get to, so I'll kind of go down to my last slide and take a question or two since we're at the end of the day, because my timing is out. It's done, isn't it? Yeah. I don't like going over. But I got into almost all the good stuff. I will mention very quickly, I've got some courses on that, on Pluralsight and LinkedIn, and the slides contain some QR codes for that, or you could just search for them. All right. Since we're at the end of the day, and I'm only 1 minute over, I can take a question or two, and then I'll let you go, because I know your neurotransmitters are depleted anyway. You're ready to get out of here. Right there.
How do you feel about color blindness in like grouping?
How do I feel about color blindness? Yes.
Red-green.
Certainly, red-green color blindness being the most common one. Typically, you don't want to rely too heavily upon color. Because of that, the first line of defense is to combine color with shape, so that they can group with shapes instead of the color. And you can still use the color for the 95% that don't have color blindness, but then you've got the shapes to help people. You can also check to see how the colors are perceived by colorblind people and maybe tweak the colors a little bit there. Any more? No, I see some people on the edge of their seats, ready to rush out. But I will take one more if there are any. Shield the lights. Okay, I hope you've had some fun and found a few interesting things that you might apply to your work. I will post the slides on the conference site, and you're welcome to contact me about them if you like. I have fun doing this session because injecting science into the art of design and development, I think is a good thing for all of us. It helps us make stuff better for our users. Thank you very much, folks, and holler at me if you need to.
Okay, we are back. It is the last session of this first day of NDC Oslo. And I would like to ask you to make a huge applause to all the organizers that made this possible. Cool. So, today we will talk about focus. So, how to be indestructible. And I'm pretty sure, being one of the last talk of the conference, that the program committee wanted to challenge myself. So it's super important that you help me to show that we can be really indestructible, right? So what we will talk about today, we will talk about why it is so important to stay focused. We will do a little bit of self-assessment. We will talk about risk. If we do not manage focus, we will show the 4 keys plus 1, because when I applied, I said, okay, there are 4 keys, but then I discovered one more, so it's 4 plus 1. But before starting, I would like to say some words about me. I'm Michela, head of community Codemotion. We have a community of 250,000 developers in Europe, but mostly in Italy and in Spain. And I'm organizer of several communities like TEDx, Google developer groups, and many others that I manage in my free time. But mostly, I come from a little village in Italy called Cissone, and we have 82 inhabitants with no internet connection and public transport. So I'm really happy to be here today. And one other of the thing that I do is that I have a new job title. I'm Chief Selfie Officer. So I would like to take a selfie with you today so that we can show that I had a great presentation, the best one ever. So please raise your hands and say, and smile. Thank you. Anke, the other side, sorry. And here. Great. So, I can go. No, I'm joking. So, well, let's start with why, as Simon Sinek says. I wanted to imagine for a moment that you are no more developer, but you have to deal with one thing that you love a lot, people. So, you are a community manager, and you organize events. You manage program and user group. You manage ambassador program, partnerships, speakers, and then scholarship, a wannabe speaker program, contributor, and you have to manage your community team and your internal team. And when you do this, you do with a lot of tools, because people get in touch with you with Instagram, email, Facebook, WhatsApp, whatever. So I can assure you that if you start working with people, it could be a little bit complicated at the very beginning, and your mind at the end of the day completely get crazy. So, how I felt after when I started to begin being a community manager. I talk with so many people all the time, making so many chats, but at the end of the day, I really feel completely stressed. And I didn't know what I did really at the during the whole day. So I said to myself, I need to manage. I need to know how to do this. And I followed a masterclass from Neil Ayerl, and he told me that we had to be indestructible. This is for us, for our mental health, physical health, our career, and our relationship, and managing our stress and concentration. There's a Google designer who says that if I'm Facebook, Twitter, Instagram, WhatsApp, we have thousands of engineers whose job is just to get more attention from you. So have you ever have this feeling like watching Netflix, for instance, and it ends the first episode, and then really quick start the second one, and you say, I'm so tired, I want to go to sleep, and then I say, okay, let's see the other episode. How many of you had this sensation? Okay. Then also the LinkedIn progress bar that shows you that you are so close, you have your perfect profile. And so it says, OK, give me some more personal data. So this is more or less the sensation, right? And there are billions of places to spend our attention. But there is a war behind this. A UX designer says, the only people who refers to their customer as user are drug dealers and technologists. So, you know, user can spend a lot of money, and it is important for our industry. And researchers show that we spend almost like 2 years of our life on socials. And it's a lot. So let's do a little bit of self-assessment. Who has problems with time management? OK, cool. Concentration? Yes. Who has problem keeping habits and routines? Cool. And being present? OK. So you are in the right place. And so this study shows that we spend almost 3.5 hours on our mobile. But this is a general study. Imagine us in our field, in the IT field, how much time we spend more. And we spend also 7 hours a day, well, we, in reality, even more, in front of a screen. But at the end, when we have to deal with like social and all this kind of stuff, have we done meaningful things for us? So have we spent time correctly? So it's time to take action. We need to be honest with ourselves and have to do with what we really want. So we can't blame always what is outside. We need to be conscious. And Paulo Coelho says that a mistake made several times becomes a decision. So what is the opposite of distraction? Someone knows? Concentration. Who agrees with this? Focus. Who says that focus is the opposite of distraction? Raise your hands. Mostly. Other answer? Okay. So the opposite of distraction is? No, is traction. So, traction is an action that brings us close to what we want. Distraction is an action that takes us away from what we want. And action starts with 2 triggers, internal ones and external ones. Only 10% of triggers that start our action to become distractive are external. So, notification, apps, friends that come to us, 90% comes from internal. So time management is pain management because distraction is an unhealthy escape from discomfort. So we want to escape from loneliness, maybe anxiety, laziness, we are bored, or we seek to escape from we feel unfair. So, and if you think social that we develop as the only aim to entertain us. So, what happens if we do not manage our focus? Well, when I had to manage and face this kind of problem, I started analyzing my routine and my morning. So, when the alarm sounds, the first thing that I did was taking my mobile and have a look on WhatsApp, Telegram, Instagram, LinkedIn, and then open emails, haven't seen if there are any kind of notification, so getting started answering to so many people, and then having breakfast while watching TV and having my mobile open. So it was really crazy. So in the first hour of my day, I had done so many things, but in reality I did nothing, and my brain was already burning out. So, which are the risks? First, stress. Due to stress, we underperform and we burn out. Second, the quality of life, both professionally and personally. Third, we overload our nervous system. So we have cognitive load and information overdose to manage. It's so hard to learn new stuff. And then the fourth, relationships. Our most important thing that we have to deal with. Because if people don't feel that you are focused and you are concentrating when you talk with them, they don't feel they're enough. There's a famous talk of Simon Sinek that says, if I'm talking with you or with my mobile in my hands, yes, it's turned off, you don't see any kind of notification, but it's like I'm not concentrating on what I'm doing. So if you are maybe having dinner with a friend or with your partner, and you have your mobile on the table, it sounds like there's something more important than me. And why should you have your mobile close to you? So mostly we miss important things. So it could happen the best thing close to us, but if we are not focused, we miss this kind of stuff. And research shows that our focus lasts 40 seconds. And if we have Slack or any kind of chat open, it is 35 before that we get distracted. So we think that it is a brain problem, because of course brain is our boss. But it's not. It's an overstimulation problem. Of course, attention is fragile and vulnerable, but especially if we are so stressed. But we can manage, because otherwise our minds start to wander. There's a thing called novelty bias. And novelty bias is based on a hormone that is called dopamine. And when you use Instagram, Snapchat, TikTok, the same hormone, that is the dopamine, is produced like when we have sex, or when we take drugs, or when we smoke. So it is exactly the same hormone that we want more, even more. So distraction is the enemy of focus. No, it is overstimulation. We need to create more space. And now I have a question with you. Did you notice something strange in my last slide? Yes. So, cool, get focused, stay focused. So, why this happen? Because we receive every moment 11 million bits of information to manage, but we're able to elaborate them consciously only 60 bits at a time. So what does this mean? That 99% what doesn't happen is unconscious. So, okay, but how? How can we manage? First of all, I would like to ask you, how many of you had classes during the years at school to know how to concentrate? Like, how many of you? One? Okay. And how many of you have been told to focus when you were young? At least one time. Okay, almost everyone. And this is funny, right? So people say us that we have to focus, but they don't explain us how. So we have a solution, and solution is training. Training exactly as we want to run a marathon. We had to start, we have to buy shoes, we need to go out to make the first steps, then to run by 500 meters, and then the first kilometers, and then in 1 year, we will be able to run our marathon, maybe. So, this is why, because we have become expert of distraction. Every single moment we get distraction from notification. Oh, I want to answer to my friends. Maybe she or her answer me, or maybe someone has answered to my LinkedIn post. So we had practiced all over the years our capacity, our skills to be distracted. So we are super expert in this. So we need to become expert also in focus. And how? Well, we need to understand how it works our mind. It's a powerful tool, right? But unfortunately, there is not a user manual. But there are neurosciences that are starting working on it and shows us some interesting tips. So, the first key, manage internal triggers. the first step is to be aware. So we need to understand ourselves. We have said that we escape from something. So the first step is to recognize what's happening in us. I know it's super hard, especially at the beginning, because we are working hard on a task and then maybe something happened in our mind. It said, okay, we don't have time to stop ourselves for a moment and say, okay, what's happening? What are you escaping from? It is boring, this task. I feel alone. I want to eat, but why? So we need to be curious. We need to be aware and know ourselves even more. Then we need to serve the urge. Here there are three kinds of person. The shamers. Shamers, people that said, I'm not good on time management. It's not something it is good for me. Then we have blamers. Blamers are people that say that are all external problems. It's just because maybe there is a friend that's come and it's not about us. But then we have claimers. Claimers are people that take responsibility on their action and they respond to that sensation. It's not our fault about how we feel, but it's our responsibility to react to that feeling. So we have the first rule, as said, manage internal triggers, and I can give you one tip. And this tip can use our biggest and powerful skill. Who is able to procrastinate? We are good procrastinator? Okay, cool. So the first rule is the 10-minute rule, and it uses our procrastination skill. So maybe you are working on a task or on a project and says, oh, I would like to see that message. Maybe my friends answer me. Or, oh, maybe there are some likes on my new post on Instagram. And then you need to put a delay from this moment until you want to do this action. So say to yourself, okay, I will do it just in 10 minutes. If you put a delay from the first trigger that it comes in your mind and your action, be sure you will not do it, because you become even more aware on what you are doing and on what's happening to you, and you understand which is the real value on this kind of things. And the other suggestion that I can give you is take always close to you a piece of paper. Yes, piece of paper and pen. Because every time that you are working on a task, for instance, and it comes to my mind, I need to say this to my colleague, just write it down. Don't do it, because if you open Slack, you will see thousands of channels that you need to say, okay, I need to just read this, and then you don't know, it's past half an hour reading messages and answering, and you don't know and you don't have any idea what you're working on. So this is the first rule. Procrastination. We are all skilled and super senior expert about procrastination, so I'm pretty sure we will be able to use this tip. Second one, take time for traction. If you call it distraction, you cannot call it distraction unless you know what you are distracting from. So I have reframed my new morning, and I've decided which are real priorities for me. So when I wake up, I open the windows, I do a little bit of earthing, then I do 10 minutes of meditation and yoga, and then I can take a cup of tea, and then I read my books, I do training, and then I open my wonderful mobile and answer to all the people that I have, and then start working. So I want to be attracted to be more productive and calm. So this is the real important things to me. So I want to start work not with a lot of things in my mind, but with a calm mind. So you need to schedule your time, otherwise someone else will do it for you. And here you can do in 3 steps. The first one, plan your time by outcome and not output. Dismiss to-do list and stop reactive work and multitasking. If you need to do it, you need to do it based on your values. So you need to schedule your time based on what you really want to do. And your metric of success shouldn't be, I have done these 10 tasks, but should be, you should answer the question, have I done all this the thing that I wanted to do in this amount of time without distracting me? If the answer is yes, you get success. So you reach that goal. If the answer is not, you can also do thousands of stuff, but you get distracted and your mind will start wandering away, and you will not feel that you reach some important goals. So the solution is this one. I know it could be a little bit, can bring with you a little bit of anxiety, maybe. This was the result on me when I saw the calendar. When I was doing this masterclass, I was saying, oh my God, I cannot shadow all my time. I need a little bit of time to breathe and to stay calm. But I didn't have any other solution, because the way in which I was behaving, I was managing my focus, my attention, my concentration, it wasn't working. So you need to schedule your day. You need to schedule your day based on your needs and values. So I wake up early in the morning at 6:30, and then I have my morning routine. Then, as said, I have masterclass training, I do training, and then I start working, have amount of time to work, to see like Gmails and all the notification, and then I have focus moment for each activity I'm working on. And I have planned also like moments, there is also lunch, because sometimes happen that I don't remember that I have to eat. So you can see that there are moments where I dance Latin American, or when I go out with friends, or I spend time with my mother, and so on. So you need to schedule your day based on what you want to do. Do you want to see a series on Netflix? Perfect. Just put it on your calendar and schedule that time for this activity. Do you want to have 2 hours to do nothing? Perfect. Let's write it down and dedicate this time only for you. So create your time, your space to be creative, but respect, of course, this kind of stuff. Did you know that we need 23 minutes to get back on focus? So if we multitask and change tasks one to another, we need so much time to get back on what we were working on. So think about how much time we lose every moment. But above this, it means that we have always less narrow resources to work on our project and our main goal. And we really think that shifting tasks one moment to another, we getting shit done, but in reality, what does it mean? So research shows that we check emails 70 times a day, and we shift tasks 576 times a day. Or we check our phone 60 times. So it's so much. Imagine how much. So we are expert multitasker, but in reality, it doesn't bring in any place. So we need to understand the power of routines. Our brains has evolved over the years, but it thinks always in the same ways of millions of thousands of years ago. So we don't take the right decision. Our brain do not want to take the right decision. Our brain wants to take the easiest decision, because we need to consume less energy as possible. So it's not more about willpower. If we do understand the power of routines, we will not think about, oh, do I need to make gym now? No, it's shallow. You just need to do it. Third, we need to turn off external triggers. This is the easiest part, because we have thousands of tools that can help us to do it. So first, you need to monitor your time. So who is aware on how much time spent every day on his mobile or her mobile. Okay, some of you, that's cool, but most of the audience, no. So be aware of how much time you spend on your mobile every single day. And then when you ask yourself, but I do not have time, well, you will find that time over there. Then, use focus mode. It's integrated in almost every app. There are apps that you can download to block other apps. You can use multiple desktops to create digital environment different for every kind of activity. But you can use personal one, or you can work on your work stuff, and put a timer on the apps. This is what I did in 2021 when I was really burning out, because people were writing me in so many moments, and I received so many notifications in every single moment. So I have first put the gray screen so that the mobile for me is less attractive. Second, I stopped some applications that I used the most, so LinkedIn, Instagram, Facebook, and X, so that on every time that I go there, I can find a notification and say, okay, you're on focus mode. Are you sure you want to go there? So there is a friction between when I click and then when I enter the app, plus less internet connection that we have in Chisone. It's perfect. So, and then, so I have focus mode from 2 p.m. until 1 p.m. Or just during lunch, I have a moment in which I can access. And then I have put a timer on each app so that I can use Instagram only 15 minutes a day. And if I want to use it for work, because of course I need it, I just use it from my computer so that everything is separated. So if you do not decide what to focus on, someone will decide for you. We need to make digital clutter. And to do it, so that you cannot be distracted. How many of you have ever seen this kind of situation on your desktop? Okay, not that far. Okay, you already have a good clutter digital environment. So the point is to pass from this moment to this. So clean everything that you have on your desktop, on your mobile, on your archive, on your Google Drive, and whatever. Because if you start to say, okay, I need to organize, you will never do it. So let's create a clear space when we can work. Make clear to your colleagues, to your family, to your flatmate when you are working. Especially for us, that we are smart working and we work remotely, this could be the situation that could happen. Like you are working on a task and say, okay, I'm so focused on finding the solution, and then my mother comes and says, hey, Michaela, sorry, can you help me this with my mobile? I don't know how to use WhatsApp. I was like, oh my God, and I miss everything. So I really want to help my mother, of course, but I had to tell her, Mom, I want to help you, but we need to do it in dedicated time. Now I'm working, and if I work, then you disrupt me. I answer you bad. I don't want to lower our quality of relationship. So this is something that I'm doing for us. So another thing is leave distracting devices out of meetings, both of work, if you can, of course, but especially personal. So as I was saying before, if you are on a dinner with your partner or with your family, with your friends, leave your distracting devices out, because you need to stay focused on what is saying the person. And here's some practical tips. You can download Forest. Forest is an app that blocks your screen because they want to grow several trees for you, and if you need to put a timer and says, okay, I want to stay focused for 10 minutes, for 30 minutes, and if you click on your mobile, they will kill the tree. So if you don't want to kill trees, it's better to stay concentrated. Or work with friends. There are, you can work co-working physically maybe with friends, or you can use focusmate.com. It's a tool, it's a website, free, where you can go and say to someone else, all around the globe, and say, okay, today I want to work on this, and this task, and I will do it in 1 hour. And he or she will do the same, and you can work both in the same moment, so having the Zoom call, we can say, open, or you can see yourself after the meeting so that you can share what you have reached. And this worked for me a lot. I didn't use this tool, but there was a moment in my life in which there was a friend that every single day asked me, what you're working on? And I said, okay, today I had to do this for the ambassador, this for the conference, and this for this new project that I'm running. And to say this to my friends, saying that I have stayed this kind of task that I had to work on, I really was more focused, because the day after he will ask me again, what we will do and what have you done? And so I need to prove that I reach my goal. And then stop your to-do list and start not to-do list. If we want to free our time, if you want to give real values and priorities so that we can be real focused on what matters for us, we need to stop doing something that's not meaningful for us. So another thing that I do, every year I set my goals, and every day I have my sheet of paper where I read all my goals so that I can be focused and see, okay, these are my goals, so if I need to do some choices today, I will do the choices based on these goals. This is the situation in which we are now. So we have a high stimulation all over the time. But what if we change this situation and turn off notification? We have a moment of boredom. So if we get bored, we can really unleash a lot of stuff. We can get more ideas and more plans. A lot of people say that the best idea we have when you have the shower, right? So this is the reason, because if we have a dedicated moment in which we want that our mind wander, we can really find solution to problems that we didn't thought. This happened to me, like I will dance Latin American music, so some solution to some problems that I wasn't able to solve arrived me while I was dancing like a salsa. Or I tried several stuff to manage time, like tomato way, so working for 50 minutes and then 10 minutes stop. In this 10-minute stop, I was workout. Yes, I did a lot of tests. So in this 10 minutes of workout, where I just was concentrating, doing exercises, really comes to my mind some activities or some solution to problems that was super useful. There's a thing called scatter focus. That's an international mind-wandering letter so that you can wander free from any point. And this is super important for us because we can calm down our mind. So not all those who wander are lost, says J.R.R. Tolkien. Last key, make pacts. We need to reduce distraction with pacts. And I want to talk to you about the myth of Ulysses. Who knows Ulysses? A few? Okay. So, Ulysses made a pact with his crew because he wanted to hear the song of the sirens. But if the crew and the whole team hear these songs, the result was they were killed all. So the crew couldn't have the possibility to hear the sounds of the voice of the sirens, but Ulysses, yes. So nothing happened. So we need to talk with ourselves and be our best friends and make pacts. There are 3 types of pacts. Pacts of money, effort, and identity. So money. Let's think about, okay, I want to do this activity today for 1 hour and a half, and I want to reach this goal. If I don't do it, I will burn 50 euro. We will do it, this activity without distraction. Who can do it? Yes, okay. So, we need to incentivize ourselves. Yes, maybe this is a little bit extreme, we can say, but this could be. But this is the rationale that there is behind when we want to have gym. We want to train ourselves. But if we think that it is free, we always postpone, so we are procrastinator ourselves. But if we pay, we will be more incentivized to go there. And this is the same also for meetups, for instance, or conferences. If we have free training, that is one, like local meetups organize a lot of free meetups, but the no-show rate is so high. Why? Because if it is free, people don't perceive the value. And so at the last time, they say, okay, I'm tired, I work all the time, why should I go? I don't go. For me, it's not valuable. But if you pay a ticket and you come to NDC Oslo and you don't want to, you maybe have a headache, maybe you think twice not to come today or tomorrow. So this is the first, based on money. Then there is the effort. So as I did before, if I put a barrier in between me and the action, as I make the telephone, my mobile, less attracted with gray, or I put another barrier, I put a timer on each barrier, or the focus mode. So in this way, I have to click on the app, and then the app shows me, yeah, but you are on focus mode, are you sure? Yes, you need to confirm. And then maybe you have the timer, and so you have the time off. Yes, of course, you can go in the settings and up your timer, but there is a lot of friction. You want to use this information, you want to go on Instagram right now, you don't want to have thousands of steps to do a thing. So if you put friction in this, it will be super easier, well. And then the identity. The identity is based on which are your values and who is the person that you want to be. Would you be a distracted person, or would you like to reach your goals? So, we need to take action. We need to master internal triggers, make time for traction, hack back external triggers, and prevent distraction with path. And these are the 4 keys, the first 4. So, as I said, manage internal trigger, find more time for traction, turn off external trigger, and make pact. But we have the +1. The +1 is reframe your lifestyle. We need to think about us globally, because we are a lot of stuff. We're not just working, okay? So we need to reframe our lifestyle. The first thing that we have to do is being mindful. Who practice mindfulness already? 1, 2, 3, 4. Oh, okay. Several of you. More this side, no. Interesting. So, mindfulness means to pay attention in the present moment on purpose without an attitude of judgment. It is not like meditation, say all the time. Of course, it could be, but mindfulness is more nothing. We are divided in the time divided into 3 phases. Now we think about the past, when you was young, and when you did that decision that completely changed your life. Maybe you blame yourself and things wasn't as you wanted, and then you think about the future. So everything that could be wrong, or things that maybe you are not expecting. But the only moment that you need to live is now. Because it is the only moment it's worth. It is the only moment that you really live. So there are so many variables for the future, and we cannot change what happened in the past. But we can live now. And mindfulness is a way in which you just need to stay concentrated on one thing without judging. And research shows that people, they have monitored people in high stress moment in which they have to do some task, and their focus were extremely low. But after 1 month in which they did 10 minutes of mindfulness every single day, their focus were higher. So you don't need to do 1 hour. I'm not able. I do just 10 minutes every day, but really it can help you a lot. Then, write. You need to visualize your thought. When you're so confused, you don't know what to manage, what you have in your life, in your mind, just write down. Give to your thought a shape, physically, on a piece of paper. You will understand that will be less thing that you were thinking about, because things in our mind are more complicated than what are in reality. So, another thing that you should do is take care of your environment, both physical and digital. So, physical, if you have a big house, maybe you can have a room dedicated to work, one to sleep, and one to eat. If you do not have, be sure to divide the spaces, because for our brains, when we mix this kind of stuff, it's so hard to manage. So, if you have only one room, just have a dedicated space for work. Don't work on your bed, for instance, because then you bring, when you have to sleep, all the thoughts of your work. So it's super hard for you to manage. Really divide the places so that you can manage better. And online, you can develop a second brain. Who knows what is a second brain? Okay, there is another talk for this. So you can, for instance, I manage several communities, and I have several Chrome profiles dedicated for each environment, and so dedicated bookmark for each one. Or on your project management tool, so create dedicated spaces for each project, so it's super easy to go and find information. And then food. Food is super important, so do not eat too much, because if you eat so much, our brain needs to give all the energy to to digest the food. So healthy food, of course. And I am not a dietologist, but research shows that blueberries are full of antioxidants, avocados, good fat as fish, omega-3, eat a lot of water, green teas, and other stuff. So food is super important also to see ourselves comprehensively. And then sleep. Sleep is super important. Who sleeps at least 7 hours and a half? 6 hours? 5 hours? 4 hours? 3 hours? Okay, I don't want to say less. So there is a beautiful book on sleep that says how much sleep is important. So it restores our mind. It helps us to remember things, clean your thoughts, so delete information that are not useful for us during the night. And it is a hormone balance. This is super important. And the CEO of Netflix says that their biggest competitor are Facebook, YouTube, and sleep. So there should be a reason why it is so important also, no? So remember, in our IT world, it works hard to attract people, to get their focus. This is the goal of all big corp, like so in social, no? So Facebook, TikTok, Netflix, they want to entertain us. They want that we use their products. But every product that we develop needs to be used. So our goal is to have the attention of people. But we need to be aware. So awareness and consciousness are the key for us to be conscious on what's happening. So we have all tools we need to be more focused. So to wrap up, manage internal triggers with 10-minute rules and procrastination. Find time for traction with planning time for outcomes and not for outputs. Dismiss to-do lists and stop reactive work. Turn off external triggers. Monitor the time you spend on your mobile. Use the focus mode. Put a timer on each app. Make digital clutter. make a clear way in which when you work. And then you can download Forest app, you can work with friends, and dismiss to-do lists. So start to not to-do list. And then make paths with about money, effort, and value, and identity. And the plus one, reframe your lifestyle. So mindfulness, writing, dividing spaces, healthy food, and sleep. And I want to let you with a challenge. So try not to take your phone when you move, when you ride a bike, when you walk, when you drive. So try to do this for a day, for a week, and see how it works. And for pro, try not to use your phone try to use the phone only for a limited time, each day. At the very beginning of the year, I decided to not to use the phone for an entire week, and I was at home, alone. And the very beginning was a little strange because I said, wow, there is so much time. What can I do in all this time? Then I found a lot of stuff. But it's quite a great experience, especially for us that we were constantly connected with everything. So I don't want to ask you to do this because I know it could be a little bit complicated, but test yourself. So challenge yourself. How much time are you really able to stay without any kind of device? So thank you very much. And here are a QR code. If you want to see all resources and bibliography, just give me a feedback and you will receive just an email directly in your inbox. Thank you very much. I don't know if there are any kind of question. You can just raise your hands or come here. Thank you. Sorry, okay. Can you put just again the QR code? Thank you.